Welcome, fellow users, to NixCon 2020 Online Edition. Please welcome your host, Roll the Beat.
Hello, everyone. I am so happy to be here. Good morning, good afternoon, good evening, wherever you are on this planet. Hello. We are back again for our second day of talks, and it's also the final day of talks. Well, it's also a hack day tomorrow, but anyways. A little about me if you're not familiar from interacting with NixOS community. Just to recap from yesterday, if you missed my introduction, it's your first time seeing this. I am gender non-binary, and my pronouns are they, them. And I've been using using NixOS and actually been a part of, I think, the organization since 2018. And I that guided that sort of decision with a great sense of intuition. I really felt that this was the right place for me, and I really couldn't have been more correct. All the achievements I've had in NixOS, aside from being one of the top contributors for I think 2 releases, and I really take those as collective wins. And I was co-release manager for NixOS 2003 and for 2009, and I'd like to think I changed lots of stuff up for the better. So if you use 2003 and your transition was you didn't even notice a change and it was just that seamless, you can partially thank me. Okay, so to recap sort of logistics in case you've forgotten, and maybe this is your first time watching this, tuning in, we have 5 more talks today. Actually, do we have 5 talks? Sorry, I'm not actually sure how many more talks we have today. But I will say that there are 25 minutes, and the last 5 minutes of a talk, speakers will have a short Q&A. But it's also possible that some speakers that aren't pre-recorded could eat into that time. And the main way to participate in the talk would be directing a question to a speaker during the Q&A. You can do this by asking your question in a free node channel called NixCon-QA, and M. Botham, our moderator, is going to feed those to me so I can direct it to this speaker. And the main NixCon channel is just for general discussion and won't be watched for questions. There are also breakout rooms for each talk, and we'll be forcing our speakers to move into these rooms after the talk ends. And you can just sort of hang in there and ask them any questions that you couldn't get answered during the Q&A portion, and just have this nice ambiance. And I believe our moderator will send the links to those, like the room key, in the NixCon channel on Freenode, and I believe all other channels that we're operating in. And lastly, if you experience any technical difficulties, you can contact our moderator in a PM, and he'll try his best to get back to you. So, with that out of the way, I would just like everyone to take this moment to just, if you're sitting down, sink into your chair. If you're standing up for some reason, feel your feet into the ground. I want you to be as relaxed as possible to just receive everyone's talks in the best way possible. This is our time to share together in this uniquely defined moment, to share our love for Nix and just broadcast it out into the world. And I would just really like if you could make it a very meaningful and important experience for everyone. Okay, with that, I'd like to thank you again, the viewers, for tuning in with us today, our organizers who, oh my gosh, work basically tirelessly or don't sleep. So if they sound tired, they probably are tired. And also our sponsors, Relational AI, nixbuild.net, Mutable, Twig, and lastly, Equinix Metal, which I will speak a little bit more about. So, in a world filled with visionaries, explainers, and thought makers, it's time to focus on the doers. That's why Equinix Metal created a developer-led ecosystem where you can be your best. A place to play with no constraints. A place that's fully focused on bare metal automation using any technology any way you want it. Build it your way from the ground up. And you can get more information about Equinix Metal at metal.equinix.com. Okay, I guess that concludes our introduction, and we'll be moving into our first talk, which is Bridging the Stepping Stones, Using Pieces of NixOS Without Full Commitment. So our speaker for this talk is going to be Michael Raskin. And an interesting thing about Michael is, You may have a hard time finding his GitHub account because it is just completely just like a random like hex dump of just random hex bytes. So I believe it's like 7C6F434C. And yeah, I always have a really hard time trying to figure out, okay, what is his like GitHub again? Because it's like just random. Okay, a little background about Michael is that he's one of the few people who stopped using mainline NixOS, but actually still uses Nix and Nix packages kernels like for more than 10 years, I believe. And he moved to NixOS from Linux from scratch. And he was actually using a separate Union FS slice for each package in that distribution. And he's a postdoc in computer science. I believe it's theoretical to applied computer science. And he started using NixOS in 2007. Okay, I believe Michael can now take it away.
Hello, I'm Michael Raskin and I will tell you about bridging the stepping stones, or how to use pieces of NixOS without full commitment to the full NixOS and without leaps of faith. So what pieces of the ecosystem you are expected to use? Well, first, Nix Package Manager. Yes, you should use it, and it lives well side by side with anything, so the only cost is maybe doubling the space you needed for installing software. Next, NixPKG's package collection. You most likely want to use it, and what's the cost? Maybe a few gigabytes of clones lying around and standard environments built, which you would build in a slightly more space efficient way, I guess. And then there is NixOS operating system distribution. Well, maybe you also want to use that. After all, what's the cost? Only changing all of your habits about how to manage an operating system installation. Of course, NixOS has a lot of nice features, and many of them are listed on the home page, but basically it boils down to 3 bullet points. Your system is Nix package and you happen to have Nix around too. If you boot up to stage 2, you are very likely to boot successfully and into a consistent state. And you have a declarative config, which is just a single expression which gets instantiated from 0 to complete and can be versioned and whatever. These are really cool features, so now you might be asking yourself, can you now finally safely experiment with all the cool stuff like init systems, operating system kernels, and services which you can override to your liking? And also, can you finally escape all these complicated interactions between the things that get installed imperatively? Unfortunately, the situation is a bit more complicated. Well, first of all, NixOS hardcodes quite a few things. First of all, it is written around a Linux kernel and systemd as the init system. And then the configuration of NixOS, this declarative thing, is done via module system, which is nice for simple things and propagates your preferences across the configuration correctly. But when you do complicated things, you notice that there are a lot of moving parts and there is a global namespace and they sometimes touch the same place in the namespace. Of course, this gets resolved automatically, but the interaction complexity is back here. And also, when you want to play with overriding services, it turns out that modules are less overridable than NixPKG's packages. And of course, NixOS hardcodes how you describe the core of your system, like you have to use this NixOS specific DSL to describe which file systems to mount on boot. On the one hand, it looks like not a lot of hardcoding, because what distribution doesn't hardcode such things? On the other hand, it turns out that inside of all this are trapped some less opinionated things, like configuration generators for multiple daemons, and also start flag knowledge for these daemons. And as an illustration that indeed there is less opinionated code that is kind of trapped inside, this knowledge is duplicated in NixDarwin, even though for a different service management system, and Home Manager, which sometimes has a duplication of functionality with NixOS with slightly different approaches in a confusing way, and of course Nix Process Management, which you will hear about later today. Of course, one can also ask, is this code really trapped? I invoke the law of headlines ending in the question mark to hear the answer. Well, it is complicated. There is a strategy how to use all this code outside the mainline NixOS installation. You just evaluate NixOS as a function, as a Nix expression, with configuration which is minimal beyond minimal. It is not enough to build a bootable NixOS or maybe even a container. It only talks about the service itself. And then you grab the parts you care about, like most likely the configuration files in the etc. And also a nice part of NixOS systemd unit generation functionality is possibility to export the contents of exec stuff to a runnable script. Thanks for that, it's really useful in many cases. By the way, I use both things I have described here on my own system to grab cups running and to get Xorg configuration. So currently all of this functionality I use is online, which allows you to grab service script by service name and NixOS configuration, and also etc file or a bunch of files in etc. And all of this is online and has been online for some time. So what are the implications and the limitations of these approaches? I claim that the main value of NixOS, which it would take the most time to replicate, even based on Nix, is a large database of configuration generators for many daemons and programs. And many services are actually already reusable, which is nice if you know how to do it and you have a use case. Of course, there are some catches. You need to pay attention because, for example, many services are configured not just under their namespace, but all over the place. And also, some services are too complicated for a working runner script to be generated automatically by the generic code. You might be able to grab the parts of the unit and slap together the correct runner script on a case-by-case basis. And then, of course, some services have configs that do not go to /dc and also do not get an option name for the contents. They just get reference inside the service starter unit, and they are annoying to grab. So you see that I said that I can replace the NixOS boot scripts, so not to run the full NixOS, but still use the services. But I said something about the module system, and what would I use instead? I would use something mimicking NixPKG's overlays, so make extensible all the things and define a small core system. And then the core system adapts by reading some parameters from self, like list of services, which might be empty by default. And in overlays, you overwrite whatever you want to reconfigure. And of course, you want to put as much as possible into this ether set and not into let instances, because you want everything to be inspectable and maybe even modifiable. On the other hand, I can say that what if not the model system is the wrong question. The other question is, can we make it not matter? The question is that services could be like packages. They could be packages with parameters, and they could provide rich pass-through, and they could request and inspect other service instances. And then it's user's choice how to ensure that everything gets passed and that every service gets as a parameter correctly configured instance of dependencies. And of course, module system would be the default, would be the only thing supported by mainline NixOS, but it would be easier to extract it and replace it, and it would be a well-defined top-level layer with clean separation of responsibilities. And another thing that NixOS kind of hardcodes is the bootloader handling, because of course NixOS assumes that it's the only thing that could want to configure bootloader based on system generations managed by Nix. And naturally it assumes that all the layout is the NixOS layout, which leads to some kind of unfortunate things, some unmodularity, like that the single Perl script generating the group entries must know how NixOS handles Zen and stuff like that. And all of this means that if you have a different system which creates system generations, it won't probably be compatible with NixOS unless I take everything that NixOS does exactly. And that's why I'm actually too lazy to dual boot with NixOS, because I would need to integrate the two lines of bootloader generation. So if I dream, what I would dream about? I would like to see NixOS services as NixPackage-like package collection with services configured by argument passing and argument overrides and maybe overlays. I would love to see module system then on top of that as one of the ways to connect things, even if the main one. And then I would love to see multiple independence options for core, like for boot scripts and stuff, arise while still sharing the service database in an efficient way. And then, to make dual booting such options more convenient between each other, maybe NixOS bootloader generator would collect bootloader configuration snippets from each system generation. Of course, that means that you need to provide snippets at once for all the bootloaders you theoretically support. And probably you would want to fail unless a special force flag is passed if booted system does not support the loader you are trying to configure for the new system, but still it could be a step forward. And if I'm dreaming anyway, I would like NixOS to gain support for atomic/etc switching. It's not completely infeasible. I do use it on my system, which is kind of similar to NixOS, and it's a symlink into store, and so one symlink change, and that's it. I promised to talk a bit about why did I even bother replacing the NixOS boot script. Well, first of all, I like that my virtual terminals are not owned by systemd, which makes it easier to do my custom tricks around launching Xorg, and also it makes it easier to write stuff like power of command is privileged not by password, by a check of physical presence. Sorry, no screencast, because it's very annoying to use Xorg screencasting software with a lot of virtual terminal switches, you know. And then my system is managed by custom written command Lisp daemon mainly. And for example, it integrates automatic NSJL wrappers, so everything I want can be run in jail, because I don't know, nobody runs browsers outside containers in 2020, right? And of course, only handpicked things have sound access, which means that my user doesn't actually have sound access, only the things that are run in jails which are specifically granted sound. And then my on-boot mounts are a mess, which is for me easier to manage as a straightforward shell script than inside NixDSL, and maybe contrary to its assumptions. And then, just for fun and ease of debugging, I have full versions of everything I have in initramfs included there. So LVM2 means full LVM2, yes, with full glibc dependency. Yes, it takes space, but it only takes space in memory until I actually switch to the main system, so who cares? And I like to have my services started via explicitly specified, nice, traceable scripts, so if something goes wrong, it's easier to debug. And what you can take out of this, if you want commitment neither to NixOS approach nor to my approach, well, you can take wrappers for piece extraction out of NixOS, as I mentioned. And then a wrapper to create an isolated debug session inside a container for something that wants the debug session but doesn't deserve access to your main one, if you even have the main debug session, because I don't. Maybe you might be interested in Firefox empty profile builder based on launching Firefox once in Xdummy. And then there is some code for converting TrueType fonts to bitmap format for Linux console, because monospace fonts often come with very good hinting, and FontForge is pretty good at converting fonts between formats. Thanks for your attention. Are there questions?
Okay, hello everyone. That was Michael Raskin, bridging and stepping stones using pieces of NixOS without full commitment. And I did get news from the channel that we did start a bit earlier than expected, so I think it was supposed to start at 7:15. So I am sorry about that. That may make it such that we don't have a lot of questions for the Q&A portion. Let me look into the pad and see if we have any questions, Michael. Yeah, I do not actually see any questions. I will also manually check the channel. NixCon Q&A. If anyone has a question, you can ask there. Yeah, I do not see a question. Yeah, I am sorry about that, Michael.
Yeah, it happens, whatever. On the other hand, maybe it means that the talk was clear enough.
Yeah, that is also a possibility. So I would say you could I will direct you to like the breakout room, which is bridging dash steps. And I'm sure that if people watch your talk later or like go back into the broadcast, they can see that and they can ask you questions from there. Oh, I think it's Puck says that 2 questions appeared just now. I will just read them from the chat, Michael. So we have one from SRHB, and she said, "Is abstracting the service generation worth it in NixOS proper? Maybe." Michael, I believe you're muted. I'm sorry.
Let me worth the word proper. Worth it in NixOS proper maybe. Well, I mean, I don't know exactly how much you want to say that NixOS is the default set of options. I believe that you want, well, I believe it's valuable to have a service database that we can reuse and that we can work on collectively regardless of our specific choices. I don't know, maybe what subset of the options should be called NixOS proper and what subsets of options should be called using the services from the NixOS database on a different system. I think that can be discussed once we have that code, once we have things to compare. I'm not sure, like, well, it's okay if NixOS is an opinionated set of choices in that regard. It's just a question of what we want to allow next to NixOS, and then we can decide what to reintegrate.
Okay, that was pretty clear to me, actually. So we have a question from Nixer 86, and they say, "It was not obvious from the talk, or I missed it, but do you still use systemd?"
Well, it turns out that I ended up not using systemd at all. And I'm not against using systemd in some container or something, but just never needed it enough. I definitely don't want to have systemd own anything on my top level namespace. And yeah, well, as I don't run it in smaller namespaces and I don't want it at the top level, I ended up without using systemd at all. Well, of course, I have everything linked against systemd libraries, but that's another story.
Okay, we have another question from Hyperfect. Oh, I know you. Hey, how does the usability of the module system and your extensibility mechanism compare in practice?
Well, in a sense, it's hard to say because for my needs, this extensibility via overlays has better transparency and easier debuggability for my specific use case. But that's another story in a sense. I never tried to use module system to have multiple people multiple people build vastly different configurations, and I cannot exclude for many people it is a very good choice to use module system because it propagates your preferences across the system well. Well, at least as long as you're inside the expectations. So it's I don't know. I didn't try to see for who. I believe that there are situations where for some people and for some settings, different approaches are more usable, more debuggable, more inspectable than the module system. And as I said, I am not sure. It might be that it's still the best choice for the mainline, most popular version of NixOS.
Okay, we have a question from Ryan TM. He says, it sounds like your suggestion to move modules to packages is maybe the opposite of Ilko's proposal yesterday. What do you think? Haha.
Well, I think the following. Well, first of all, as of me not addressing at all any of Elko's points, kind of sorry, but World of Peace can confirm that my recording has been finished before I had any chance to see Elko's talk yesterday. And on the other hand, yeah, I think the following. I do believe that, well, when I looked yesterday, for example, at the slides of Elka's talk, I was a bit worried. Then you say, okay, and you can overwrite the configs of the module you extend. And then I saw the config override, and it was just global override. And so, it's complicated. So I thought that, okay, so what are the scoping rules? I think that for putting modules inside Nix, things like scoping rules, not to stop being, a purely functional programming language, which gives you at least an option to have full referential transparency, not only formally, but also really, and to avoid global namespaces if you want to avoid the global namespaces and so on. I think Nix, being a purely functional programming language, was very valuable from the very beginning and is still valuable now. And so I believe, yeah, as I said, I believe that module system is a good thing at some levels, but I believe there are layers that are better done as pure functions and fully expectable plain data structures.
Okay, looking at the pad again for more questions. I do not see any.
I think what Virik asked, what's my init? As for my init system, well, it turns out that if you have a small enough desktop system and you actually want to see and control what is there and how it runs, it turns out that if you have just a few things and you immediately observe whether they are working or not, and you restart them for unrelated reasons anyway, like I restart my local bin when I change the network I'm connected to, for just so that it reconfigures itself a bit. It turns out that in this situation, I don't even need a real init system in a sense. So I do have PID1, obviously, and PID1 is intended as an init system, and it is static init as init from SACLS. I don't like everything SACLS does. In the sense I don't find useful for me all the tools SACLS produce. But as init, I looked at it and it does exactly what I wanted it to do. And so, yeah, my init is as init. And then I have, as I said, I have this Jumper daemon which manages my system. In particular, it launches the few daemons I want to have running on my system. So, and that's it, more or less. And somehow it turns out that on a simple enough system with enough RAM, and they happen to have enough RAM, CUPS doesn't crash, Bint doesn't crash on its own, Xorg doesn't crash on its own. And then what is even there for a true system supervisor to monitor?
Okay, great. Oh, we have another question. Is there something else apart from NSJail that I could check to learn more about your jail setup? It sounds like you're going to prison.
Well, I mean, as you I hope at some point, yeah, I will at some point publish the slides, I guess, and I hope that the recording will be there. There is, well, most of my setup, because of course there are some small things which are very local, like some of the specific host names and stuff, which might not be fully included. But generally, I have most of my setup online in my GitHub account as LangOS. And yeah, well, you can look at this, but basically it's a lot, well, basically it's just using NSJail, and then there is a lot of things that you need to tell to NSJail to comfortably rope some application. I need to tell NSJail what directories to provide to the application, what of them to provide read-only or read-write. I also run NSJail under a specific user ID, which is unique for every application during a single session and stuff like that. And I set the environment variables, of course, because of course you need to set up stuff. But basically, well, it's a piece of code to generate a ton of flags to NSJail, I would say.
Okay, great answer, actually. I don't see any more questions in the Q&A portion, so I believe that would lead us into the closing. Thank you so much for being here, Michael. It seems that you get to have a very basically an extended Q&A portion because we started early.
Yeah, thank you.
Yep, nice having you. And if everyone wants to follow in on more questions for Michael, we will be forcing him into the Bridging-Steps Jitsi room where you can continue discussion and stuff like that. Okay, and because we started early, I do have a brief announcement that the break will be longer because of that. And the next talk starts at the 45-minute mark on the hour. And I will see all of you then. And please remember to put those, put those claps into the NixCon channel. Show the love. I'm watching you. Bye. See you soon. Our next talk is Nix Process Management, an experimental Nix-based process manager agnostic framework, and the presenter is named Sander Vanderberg. This talk is about complementing Nix with any process manager. And a little bit more information about Sander, if you're not familiar, is that he is a Nix contributor since 2007 who's worked on so many things, such as the FHS root environments and the Nix Android build environment. And is a developer, well, the main developer for various Nix-related utilities such as DisNix, Dysnomia, Node2Nix, and Composer to Nix. And I would also suspect that a lot of NixOS users have probably encountered Sander's blog, which is sandervanderberg.blogspot.com. Okay, with that out of the way, you can free to start, Sander.
Okay, thank you for the kind introduction. So, hello everybody. This presentation is going to be about a personal research project that I've been working on in the last year or so. And I think it addresses a very important shortcoming of basically the tools in the Nix ecosystem. So, as you may probably already know, the Nix Package Manager is a powerful solution. So, it offers all kinds of nice features like you can conveniently construct packages from source code and all its required build time dependencies. It offers build determinism, transparent binary deployments by downloading existing builds from a binary cache. It allows you to store multiple versions and variants of the same package safely next to each other. You can do unprivileged user deployments, so if you want to install packages, you don't need to be root. It can also be used on multiple operating systems, so in addition to Linux, it is also well supported on macOS, and very recently FreeBSD was also accepted into the FreeBSD port tree. And with some little effort, you can also use it on other Unix-like operating systems as well. So when I have to explain Nix to newcomers, what I typically use is a Nix shell example to show all kinds of nice, interesting properties of Nix. So for example, if you're on a conventional Linux distribution and you want to install with packages like Python or Node.js, you may already have a version of Python installed on your machine, and you may not have installed Node.js on your machine yet. And what you can conveniently do is you can spawn a shell session in which you have a certain version of Python and Node.js. And the Nix Package Manager will automatically install it. And in this shell session, you can basically use these development utilities. And the nice thing is, because they're stored in a Nix store, they will not conflict with other versions of packages, and they won't interfere with packages installed on your host system either. So when I show this to people, especially newcomers, they typically get quite happy. Basically what they tell me is, yes, this is exactly what I'm looking for. So I'm going to experiment with packages. I'll try to install PostgreSQL or the Apache web server or Nginx because Nix is a very convenient tool to experiment with packages. And then I have to disappoint people because I have to explain them Nix is a package manager. It's not a service manager. So you can install, for example, the Apache web servers on your machine, but it just provides you the executable. You're still responsible for configuring the service yourself and also make sure that the life cycle of the process gets managed. And in order to do that, you basically need to use some other tool like systemd. And that is actually quite confusing for newcomers. So what I also typically do is I explain newcomers that there is, of course, the Nix Package Manager, but there are also sister projects that can complement Nix with all kinds of other deployment features, such as process management. And I think the most famous project is NixOS. So NixOS can generate systemd unit files with the package manager, and then systemd is responsible for managing the lifecycle of these processes. But there's one catch. If you want to use NixOS, that basically means that you're forced to adapt a fully Nix managed Linux distribution. And if you want to use another operating system, or if you're not familiar to Nix yet, this is typically a pain. For seasoned users like me, this is not a big deal. This is actually what I want, but it's not always an option to use NixOS. The same thing, for example, applies to macOS. So on macOS, there is a project called NixDarwin that offers all kinds of system services that you can manage with LaunchD. But obviously, it's limited to macOS only. So people typically tell me when they're on conventional Linux distributions, yeah, perhaps I should use Docker because, yeah, with Docker I can manage services. And then I can, of course, also tell people that Nix is also an interesting solution to use in combination with Docker. You can basically use Nix in the construction of images. You can even use Nix to build Docker images completely. And these images are typically way more space efficient than conventional Docker images. But this is not always a compelling use case because what we're basically doing is we squeeze Nix into a Docker workflow, but it's not a Nix-driven deployment process. So this is basically my motivation to start developing the Nix process management framework. So it's basically a general solution for complementing Nix with process management facilities. And it's built around a number of key concepts. So first of all, it's entirely Nix-driven. So the idea is that you write system configurations completely in the Nix expression language. It's also based on simple conventions. That means you follow the similar conventions to how packages are organized in the Nix packages repository. So the idea is that for running processes, you write a function definition, and to compose running process instances, you define an attribute set with function invocations. And a nice small extension to this framework is that you can also organize process dependencies with the same formalism as well. And the framework will automatically arrange the ordering if needed, so that, for example, processes are activated in the right order. Another key concept is that it's process manager agnostic. So it's not designed for a specific solution, but it should work with all kinds of process managers. So currently you can use System 5 init scripts, supervisor-d, systemd, launchd, BSD RC scripts, and Windows services on Cygwin. But the nice thing is the model is flexible enough that you can even use it with solutions that are not qualified as process managers. So you can, for example, also use it in combination with Disnix and Docker. And the reason why you can do that is these solutions are multifunctional solutions and they can also organize processes. So in the framework, we can basically use these properties for basically all kinds of interesting reasons. It's also operating system agnostic because it supports process managers on a variety of operating systems, and Nix is portable to some degree as well. You can also use it for unprivileged user installations, and the reason why that is possible is because I built in a global switch that allows you to disable the creation of users and changing user permissions. So as a non-root user, you typically don't have the permissions to do this, and by disabling it, you can basically just run any process you want without restrictions. And the final key concept is that it doesn't require any advanced concepts like namespaces and C groups that are commonly used for containers. So the solution relies on conflict avoidance rather than isolation. And that is, for example, good for portability, as I'll explain later in this presentation. So to explain you how the framework works, I developed a very simple example system. It's actually quite an over-engineered example, but I think it's quite easy to understand how it works. So basically, this is a web application system that consists of multiple running processes. What you see on the right of this diagram are 3 web application processes. So they're basically processes with an embedded HTTP server. And the only purpose of these web applications is to render a static HTML page, that basically states the identity of the service. In front of the web application process, there's Nginx that acts as a reverse proxy, and Nginx basically redirects users to the web application process instances based on the virtual host header field. So, for example, if the user in the web browser opens the URL webapp1.local, then Nginx will redirect the user to the first web application instance. Likewise, if you use web app 2.local, then the user gets redirected to the second web app instance. So, in order to automate the deployment of this system, so we have 4 process instances. You need to write Nix expressions for each process instance. And one way of doing that is by specifically writing Nix expressions for a process and a specific service manager, such as System 5 init. And this is basically what a Nix expression looks like. So, as you may probably notice, this is actually quite similar to the convention of how we in the Nix package manager declare packages. So this is a function definition. The first line is basically the function header. And these refer to all the build inputs that are required to generate a System 5 init script. So create System 5 init script is an abstraction function that allows you to basically generate a huge shell script with deployment activities. Web app refers to the web app application executable, and port refers to the TCP port number that the server should bind to. And what I do in the body is I invoke the function abstraction, and I basically specify what all the deployment activities should look like. So this, for example, is the start activity. It starts the executable, and it uses the -d parameter to specify that it should run in daemon mode. The stop activity is stopping the executable. The restart activity is basically calling stop and start. And status is basically used to basically show whether the process is running or not. The run levels parameter is to specify the run level. So I don't know if you still recall System 5 init scripts that we used to develop 10 years ago. So when you boot in run level 3, that is typically used to boot in terminal mode, and run level 5 is used to boot a graphical desktop environment. And basically this parameter states that the service should start on boot up for all these 3 run levels. Now, writing a System 5 init script is a bit verbose. So if I have to, for example, package another process like Nginx, then I end up repeating the same patterns over and over again. So what I also did is I developed a higher level abstraction function for System 5 init scripts that look like this. So instead of specifying the activities, what I do is I specify the process that I want to manage. So this is the executable I want to manage with this command line parameter. And basically what the function abstraction does is it infers the activities automatically. So basically the result of evaluating this function invocation is this. So the framework also has abstraction functions for other service managers. So this is System 5 init, but maybe I want to use systemd instead. So this is basically the function abstraction that you can use to generate systemd unit configuration files. So again, what I do here is I basically specify here what executable I want to manage and to which TCP port it should bind. And basically what this function abstraction does is it generates a systemd unit configuration file with nearly an identical structure. So this is pretty much a one-on-one translation from a Nix expression to a systemd unit configuration file. And the framework is basically full of other abstraction functions for all kinds of process managers. So there's also, for example, the create supervisor D program abstraction function. There's an abstraction function for launchd, for BSDR scripts, and many more. Now, the interesting thing is, if I would compare, for example, the systemd expression with the System 5 expression that I've shown in the previous slide, then you see that they're slightly different, but they're not all that different. They're still mostly the same. So what I also did in the framework is I created an abstraction function that abstracts over all these process manager specific abstraction functions. And that basically looks like this. So what I do in this particular Nix expression is I use a generic create manage process function that basically describes from a high level perspective, what process do I want to manage? And these concepts can be easily translated to function invocations to the target specific abstraction functions. And basically any process manager in the framework is supported. So System 5, launchd, systemd, they can all work with a high level specification like this. The only thing that you need to do is systemd prefers to work with processes that run in the foreground, whereas system5 init wants processes to demonize on their own. What you need to specify is basically for both foreground processes and daemon processes, what kind of additional settings do they require? So this daemon args parameter basically specifies if the process needs to demonize, then pass these command line arguments to the executable. And if you want to run as a foreground process, basically nothing is required. Actually, specifying foreground process and daemons is not a strict requirement. They can also be simulated, but for an optimal user experience, it's important that you still make a distinction between those two. Then there's one more concept that I need to explain. So in the example that I've shown you earlier, we want to run web app processes, but we actually need multiple instances of them. We need 3 of them. To be able to construct multiple web application instances, you need to follow a slightly different convention. So basically what I do here is I declare a nested function, and the outer function are basically, so the first line is referring to parameters that apply to all web app process instances, and the inner function header refers to parameters that are instance specific. And if you specify a unique combination of these parameters, then multiple instances can coexist on the same machine. So for example, the port number, only one service can bind to a specific port number. But if you allow every instance to bind to a unique port number, they can coexist. And the same thing applies to the instance name. So normally, when you launch a process as a daemon file, the PID file has the same name as the daemon. But if you want to run multiple instances, you have to generate PID files with unique names. And basically, the instance name parameter is a high-level concept that allows you to basically generate unique PID file names so that processes can coexist. So, in addition to declaring constructor functions that you can use to create process instances, you also need to actually specify what process instances you need. And that is done in a composition model that looks like this. So, again, this is similar to the top-level expression in the Nix packages collection. Again, this declares a function. So these are parameters that basically apply to all...
excuse me, Sander. Sorry to interrupt you.
Yes.
You're in, your Q&A portion is in about 3 minutes, so you'll be eating into that.
Oh, yeah, I'm almost done. So these properties apply to all running instances. And what I do here is, I construct 2 web app instances. They can coexist because they have a unique port number and instance suffix. And what I'll do in this expression as well, I construct an Nginx reverse proxy. And that is basically responsible for setting up the redirection. So I'm actually going to take a risk now. I'll show you that this is basically the example. And I can basically deploy it as any... So this basically deploys the entire system as a collection of system5 init scripts. And as you can see, it deploys 5 instances of the web application and 2 Nginx instances. And this basically shows that the redirection is working. So now the first instance is responding. And now the second instance is responding. And I can also undeploy the system like this. And now it's not running anymore. I can also deploy it as systemd scripts. So if I change the command line instruction from system5 init to systemd, I can deploy the entire system as systemd init scripts. And as you can see, the system responds again. And if I request a process overview, then you can also see that the system is running. So I basically use one single specification to deploy the system for multiple process managers. So I'm almost done, so I'll just wrap up because I'm running out of time. There are lots of more interesting combinations possible, so You can also deploy in FreeBSD as BSD-RC scripts. You can even deploy Docker containers for the process instances. Yeah, there are lots of other features possible that I haven't explained. So you can also basically create users and groups so that processors run as unprivileged users. You can automatically assign port numbers, user IDs, and group IDs. You can also combine the Nix process management with framework with DisNix. And the nice thing is that you can deploy processes to networks of machines. And you can also combine them with things that aren't processes. So for example, Apache Tomcat can be managed as a process, but you can also deploy Java web applications to that running Tomcat instance. So this is very nice to deploy very heterogeneous systems.
Okay, thank you, Sander. Is that the end of your presentation?
Yeah, it's pretty much done. So yeah, there's some future work, and if you want to play around it, this is the link. And yeah, that's pretty much it. So
okay, so we have about I think 5 questions. I will start with the first one. This one is from Niku on IRC, and they said, do you think that NixOS, Nix Darwin, and other projects managing services around Nix packages could, in the near future, move to such an abstraction layer and share more source definitions, etc.?
I think that is very well possible, but yeah, the biggest problem we have to overcome that is related to Eelco's discussion from yesterday is the module system, for example, is somewhat problematic if you want to support features like being able to construct multiple instances of processes, because modules are basically not units of instantiation. So that is a problem. There are actually concepts that you can integrate into the framework. So for example, the translation process from a high-level specification to any process manager, that is actually also something you could integrate in the module system. Basically, the concepts are, I think, very generic. So what we could also in theory do in Nix packages is we have a systemd layer and perhaps a launched layer. And we also implement a module that resides somewhere in the middle of the translation process. So a generic process management layer. And if we use that, then we can already, with the same specifications, support multiple process managers. Of course, another small thing we need to do is we need to be able to use this service layer separately, but I think that is something we can easily overcome. So.
Awesome. All this is actually really interesting to me. I was like super surprised with your presentation.
Yeah.
Yeah. So another question we have is how do you envision to generalize some systemd specific features like hardening or socket activation that some services use?
Yeah, that's a good question. So socket activation, for example, that is a concept that also launched supports. But the sad thing is that they don't follow the same protocol. So it's fair. I don't think it's impossible to generalize that, but I think it's very difficult. So what you can, of course, still do is you can define overrides for the process managers that you want. So you can basically, if some service needs socket activation, then you can, for example, declare for launched do this, and for systemd do something else. Yeah, sadly, you can't use a generalized concept, but it's still possible to address these deficiencies with overrides if you want to.
Great. And I think we have one more question, a pretty short one, I think. So by running processes as different user and group, do you mean running a service as a proper system service? So not a user service anymore?
Yeah, that's exactly what I mean, yeah.
Okay. And another one, which I'm not sure you'll have time to completely finish, but we'll give you a minute, is what about a static process manager? E.g., doing a topological sort at Nix build time to output a certain derivation representing the processes which will run at runtime.
I'm not sure if I completely understood the concept of static process manager, but that is actually already possible if you combine this framework with this Nix as a process management backend. It uses the Nix language to basically generate a dependency tree. And the only thing this Nix does is it invokes a module that simply starts the process. So that is already somewhat possible. The framework is not really designed to statically generate dependency trees itself. It only tries to utilize the features of the process manager backends as well as it could possibly do.
Okay, great. Thank you so much. We are now out of time for the Q&A portion. There's some like really interesting sort of crossover between the talks happening here, I think, which is pretty cool. So yeah, thanks. And everyone, please remember to put those clapping emojis in the IRC chat and show the love. Yeah, and the breakout room for this talk, since it seems to be pretty lively Q&A going on here, is Nix-process management, and management being MGMT, like an acronym.
Yeah.
Yep. Okay, everyone. See you
Thank
all
you.
in 5 minutes. Hello, we are back with automating deployments with Hercules CI and NixOps. And it's actually funny because a while back I did an office hours with Robert on the same topic. So this talk is an introduction to Hercules CI, NixOps, and a step-by-step demonstration of setting up a continuous delivery pipeline with these tools. Really cool. So about Robert, he started using Nix in 2015, and as you've heard, he is the founder of Hercules CI, the CI/CD service for Nix-based projects. He also wrote Arion, a Docker Compose wrapper for Nixify local development. He also wrote gitignore.nix, and he co-maintains the NixOS module system, pre-commit hooks, and Docker tools. Okay, with that out of the way, you can go ahead, Robert.
All right, thank you, Wolf.
Sorry, 1 second. I should also mention, Robert is having a bit of issue with background noise, so he may be a little bit quiet. He's gonna do his best to be as loud as possible so we can hear him.
All right, thank you, World of Peace. Yeah, so first of all, thank you so much for organizing this event. It's been excellent so far. Yeah, so let's get started. So we'll be looking at NixOps first. It'll be a very short introduction. Then I'll explain a bit about Hercules CI, and then we'll have a look at using Hercules CI effects to achieve continuous deployment. And yeah, so it won't be exactly the step-by-step demo that I promised, I guess. Made a bit of a last-minute decision to well, not do a live demo. But I'll give a tour of how effects can be used, and specifically the run NixOps function. We'll see some of the internals and how to use it, and we'll yeah, and I'll end with a short section about the future of Hercules CI. So NixOps is the deployment tool in the Nix ecosystem. There's other deployment tools, but this is the big one. You can declare your deployment by specifying the nodes. You can specify cloud resources as well, and the attributes of those cloud resources, like IP addresses of external services and whatnot, can be inserted into your NixOS configurations. So it gives you a lot of flexibility with writing your deployments. So this is a host name, and this is just a NixOS configuration, and some more of that, resources, all go into the NixOps file. And then there's the NixOps command, which you can use to actually deploy it and perform operations tasks like SSH to machines or copying files, that kind of thing. And it's been around for a while, and I think it kind of shows. But there's also some progress being made with NixOps 2.0. So there's a bunch of commands that work with the local state of NixOps. You can have multiple deployments, which you can list, create more of them, and those deployments in the local state, they know where the Nix files are, so you may have to modify those deployments, well, in various ways. And well, it's obviously from before NixFlakes, so it also relies on NixCloud. So these are going to be well, kind of challenges, I guess, when writing an effect for them. So Hercules CI is well, the Nix-based continuous integration service. Of course, there's other solutions as well, like Hydra, but the benefit of Hercules CI is that you don't have to host the server, which is arguably the most maintenance-intensive part of the CI system. Instead, it works with just build agents. Build agents contact the service in the cloud and pick up work from there. So it's a nice low maintenance setup. And it looks like this. In your repo, you write a Nix file called ci.nix. Any packages that you put in there, they will be built and automatically uploaded to a binary cache if you have one. And the new feature is effects for stuff like continuous delivery. We have live logs nowadays, and yeah. So effects are written using derivations, but they're not quite derivations. It's actually similar to how Nix shell isn't supposed to be built. It's basically the same trick that we're using here to declare how some operation should be executed. It's executed in its own sandbox, which has network access, complete access to the root file system. It can read secrets. Secrets will be configured on the agent machine, so Hercules CI service doesn't need to know about them, which is great for security. And they also have access to a state API, which is useful for, well, for example, the NixOS state that I mentioned earlier. Yeah, so it's going to be a tour. We're going to see quite a bit of code that you don't have to understand everything. So I thought it was a good idea to, well, basically show that it's really not that complicated. That's very important here, that we're just using a function that's been written already. So basically to have an effect, you create an attribute and you assign the result of the run NixOps function to it. That means it will be picked up by the agent, and after the build succeeds, the effects will run. Yeah, so you can see the basic arguments here. You specify the source and which files to actually load, and secrets, and yeah, a little bit of setup, and that's about it. So, like I mentioned, they're basically derivations, but we're using a different set of phases, and there's a special attribute to mark the effects as such. So these are the essential ones. You can have a source attribute. That's great if you need to do evaluation. You can do evaluation inside the effect sandbox. So there's the standard unpack and patch phase, and the effect phase, which is where most of the magic happens. And we have some additional phases for stuff like getting state files and writing them out. This also takes care of like when there's an error. You probably don't want to put the state back. Well, it depends on your deployment strategy. Yeah, so let's start with the state files. Directory CI effects, when you're using the library for it, you also get a bunch of bash functions to well, get the state file from the server and put it back when you're done. And you can use the hooks system from standard env to add some extra behavior to it. So in this case, with NixOS, we want to import that state into the NixOps state file. So this is an export. Probably should have called an export, but we're treating it as the only state of the deployment. So we import it, we export it. It's actually a bit more complicated because when it's not there yet, we want to create it. And well, we have to deal with the modify and the set args. But that's all taken care of. Yeah, so the state files, they're uploaded to the server. Currently, they are not encrypted on the agent yet. That's something I'm going to build. So for now, it's usable, but it will be even more secure. So they're visible here. You can change them. You can download the state file, and there's also a history of each state file. So, for example, if your state is corrupted for whatever reason, you'll be able to revert to a known valid state. All right, so next up, secrets. We always have to deal with like cloud providers and authentication for them. So, it's unavoidable to have those. They are configured on the agent in a file. It's a JSON file, and it looks like this. It's a tiny bit boilerplatey because, well, basically here there's going to be a way to configure your policies. So not every repo can access every, well, not every branch can access every secret. And it's JSON, so the secrets can be structured data, or you can just have a file in here. More about that later. So effects library provides a bunch of bash functions to write these secrets to the locations where they're expected. And that's useful because, well, it doesn't look like much of a hassle. Typically, at least when I'm writing this kind of thing, I forget about like a make there call, and I get the formatting wrong and whatever. So I think it's really nice to have these functions, these helper functions to make that just a little bit nicer. Yeah, so that's actually sufficient to get a deployment up. Yeah, but we're now running effects on every run. So that means that all your feature branches are going to be deploying to your environment all the time, interleaving. That's not something you want. So we need a solution for that. And luckily, we have a programming language at our disposal. And so we can just program a solution. So this is the run if function. Basically, you give it a Boolean And if it's true, it's going to actually run the effect. And if it's false, it'll just build the dependencies. So when you integrate that, it'll look like this. The master version of the agent passes the ref of the source, so you can check whether it's the right branch, and then only actually deploy when you're building from master. And that'll then look like this. I don't think the example has the pre-built attribute. That's also in there, so you can actually see when you're working on a feature branch that's not deploying. You can see whether it's a failure in your deployment specification, or perhaps the build tooling has a build failure, which is also possible. You can see at a glance which one is the case. So deployment succeeded, but now we can't really use NixOS because we don't have the state file yet. You can download it from the UI, but that's going to be rather tedious. So instead, we can use the Hercules CLI. You just need to log in. So HCI login, you get a link, and you click the authorize button, and you can get your state on the command line. I think this works, and this syntax is great for scripting, but in the end, what you really want is to have this behavior in NixOS, which is kind of close, I guess. I've seen the work on NixOS 2. That also includes support for remote state files. That's still in progress. So I hope I can help out with that and really make this super easy, so you don't have to write your own scripts to get this state and put it back if it changes. So that can all be automatic. So you just have to call this as usual. That's the goal. So yeah, to conclude, we now have a setup where we have a build agent that's running locally on the local network, and we can deploy from there. We don't have to maintain a CI server, and we have a deployment configuration that's all Nix. So no YAML taken care of. Hercules CI just uses the GitHub permissions. So to work with the state files, for example, you need write access to the repo. So there's really not much to configure there. Yeah, so effects aren't quite done yet. They're a beta feature. Like the top priority right now is documentation. This effects feature is like really fresh. So yeah, this the next thing I'll be working on is making some excellent documentation for this. Because the goal is, well, to make Hercules CI the easiest CI/CD system for Nix users. And I'll be making improvements to the secrets. So kind of mentioned that the state file isn't encrypted yet. So what I really want to do is encrypt both the state files and secrets using asymmetric cryptography. So it'll be much easier to share those secrets and make the state files more secure. I'll be writing more effect functions. Right now we have functions for NixOS, NixDarwin, and Arion. So I'm planning to also write one for Terraform soon, and a simple NixOS deployer. You don't always need to use NixOps for your deployments. If you're just deploying one machine, or maybe a couple of them, you can, if those machines already exist, you can just use NixOS rebuild to deploy to them via SSH. Yeah, I'll be making more improvements to the deployment lifecycle, like the possibility to run effects when the branch is deleted. That might be useful. Also, pull requests can be modeled that way. Yeah, so I guess that's the future for effects. And for Hercules CI, it's been a bit of a painful choice, but it's the obvious one. Hercules CI has been a bit on the expensive side, and I think right now it's best to increase adoption. The only way to do that is with competitive pricing. So prices will be about half, and I'll announce the exact prices soon. We have a trial period of 1 month, so the prices will be updated well within that period. I think in the next week it should definitely be on the site. Yeah, on a more higher level, I think it would be great to invest more in the Nix community. I've been doing so with some pull requests and whatnot, reviewing, co-maintaining some stuff.
Hey, Robert, we have 2 minutes left for Q&A.
All right, thanks. Yeah, so I hope that Hercules CI will be successful, so I can invest more in the Nix community. And I guess what I'm trying to say is sort of goes both ways. Yeah. So thank you.
So I think we have time for maybe 1 or 2 questions. So the first one I will tell you is, does your threat model for secrets explicitly address the case of correctly building malicious PRs with functionality designed to steal your secrets? And if so, how? I hope that's an okay question.
Right. So that's not built yet. Right now, the threat model is basically to trust everyone with rights access to the repo itself. If you're using secrets with a public repo, actually external pull requests from forks, they won't be built. So as long as only trustworthy collaborators are on the repo, it should be fine. That's not the end state, of course. I've mentioned the policies feature. I'm going to build that to make it possible to enforce that only certain branches or certain people can actually make use of those secrets.
Right. Okay, and the last question we have is, what is the risk for vendor lock-in when using your system?
I don't think that's a great risk. Because well, it's really just NixCode. You're writing NixCode, so definitely your derivations are just regular ones, and with effects. Well, I guess for each CI system this is different. I'd be happy to collaborate on some sort of standardization effort if people are interested in that kind of thing.
Right.
Yeah, so I don't think that the login is any more than any other.
I would agree. Yeah. Thank you so much. We are out of time. I really enjoyed your talk. The like sort of interface you have going on here for developers is really nice. Like it's really sleek, such as the bash functions. You made it pretty easy for people to use this.
Cool. Good to hear. Thank you.
Yep. Thank you very much. So everyone, please remember, put those ones, clap, show the love for this wonderful, wonderful talk. And I have one announcement after this is that following this talk, we are going to be doing lightning talks, okay? And we are cutting to the 5-minute break. See you then. Okay, hello, we are back with lightning talk. So if you're not familiar with a lightning talk, it really is just simply a 5-minute talk given, so it has to be very quick for that person, and I believe most of these are pre-recorded. So our first lightning talk is called Content Address Derivations. This is by Theophane Hofschmidt. And I don't actually have an abstract about that, so I will just let you cue the clip, Puck.
Hello everyone, I'm Theophan from Twig.io, and I'm gonna talk to you today about content address derivations in Nix, which is something I've been working on for the past few months with the help of John Erickson and Elko in particular. So before explaining what content address derivations are and why they're awesome, let me get back to the classical derivations in Nix, which are input address derivations. So the distinction between input and output content address derivations has to do with the way Nix computes the hash of the output path of the derivation, rather the output path themselves, which are the thing with a big hash under /nix/store. So for input address derivations, what happens is that each derivation, like hello.grv, has a bunch of inputs, be they files or other derivations or strings in the derivation, including the build command itself or the environment variable that's going to be available here in the build environment. And all these inputs will be assigned a hash. And then Nix will take all of these hashes, put them in a box, shake the box, and hash the result, and this is going to be the hash of the hello derivation, and from this hash Nix will be able to compute the different output path of the derivation. So this is Nix as we know it, how Nix has been working for the last 15 years, and it's really cool because if I somehow change my input GCC, it's going to get assigned a new hash, and transitively hello is going to get assigned a new hash, and so Nix knows that it has to rebuild both GCC and hello, and both the old and the new can coexist in the store. I can roll back, I can do whatever I want. That's wonderful. The thing that's not wonderful, though, is that maybe I'm a perfectionist, and I just happened to be skimming through the GCC codebase, and I found a typo in a comment. So I fixed that, because I can't live with the idea that one of my dependencies has a typo in a comment. But by doing that, I changed the hash of the GCC derivation, and well, I have to rebuild GCC, but more importantly, I have to rebuild my own hello project. And I don't want to do that because what I know is that I just change a comment, which means that the GCC executable will be the same, and which means that I know that my hello, the output of my hello dependency will also be the same because it had, in a way, the same inputs, the same hello.c source file, the same bash derivation, the same build command, and the same GCC binary. But Nix doesn't know that just change in a comment is not meaningful. It doesn't know what a comment is anyways. All it sees is that I changed the source of GCC, which means that I changed the GCC derivation, which means that I changed everything that was depending on it. Content address derivations take a different path. The idea is that rather than having hello.gv directly depending on the GCC or bash derivations, it depends on the output path. So what happens is that Nix is first going to build GCC. This is going to yield some output path. And then Nix is going to hash the content of that output path. And this will be the hash of the output path, this ABCD hash you can see. And likewise, Nix is going to build bash, and it's going to hash the output path of bash. And these two hashes is what is going to be fed into the Nix hashing process for hello.grv rather than the hash of the GCC and bash derivations themselves. This means that if I change my GCC derivation, so changes its hash, but in a way that keeps the same output, then hello.grv will have the same inputs effectively, and so it won't be invalidated and I won't have to rebuild it. So that's really hand-waving how content address derivation work, of course. But that should hopefully give you the high-level idea of how it works and how it's useful. And I'm pretty sure that this is going to unlock a whole new range of potential use cases for Nix, and I'm eagerly waiting for it to land in a released Nix version, which I hope is going to happen soon. Thank you everyone for your time, and you can reach me if you need everywhere there. Just not this weekend because I'm off right now, but thanks everyone.
Okay, everyone go off for Theophane or I'll be really disappointed. Okay, next up is Nix from the Dark Ages without Root. This is by Rohit Goswami, and this talk is centralized on comments from the trenches of high-performance clusters on working with Nix on kernel-locked and systems without peer support. So go on.
Good morning, I'm Rohit Goswami, and I'm going to be talking about Nix from the Dark Ages without Root. It's a short talk, so I'm just going to run through this quickly. So, first and foremost, hello NixCon. This is my first NixCon, and I'm super excited to be here. This is me. You can check that out later. So, what's the big picture? What is going on? Well, on the right, you'll see an academic cluster, a picture from GE Research. And what's the problem, really? Well, there's no Docker. If you're very lucky, or in some places you might have Singularity, you won't have any user space support, which means you can't play around with proot, and it probably runs CentOS or something, as you can see in the lower right. If you check this out later, then you'll probably also be able to see that these are typically quite powerful. That's the whole point of using them. There's a lot of power in these clusters. And there's also a network file system, typically LusterFS or ClusterFS, or even in some cases NFS. And there's always a resource queue, either through Slurm or PBStork or something like that. Again, if you're lucky, your mileage may vary. You might find support for lmod, which is a path helper, as some of you might know. And why is this? Like, why does it run an old CentOS? Why, what's going on? Well, it's a necessary evil. Users can't be trusted. There are a lot of resources which are being consumed, and you have to track these because people pay for them. But, users do need new software, developers especially. A lot of my work involves a lot of high-performance coding, and I need to know reproducibly that my stuff works. So Nix is the solution, clearly, and it's been adopted by some in the scientific community. It's been around for a long time now. It's 16 years, yeah. But does no one use it? That's not exactly true. There are clusters which use it. They have good support, like Gricard even has an ACM paper on it, and from the Flatiron Institute and Compute Canada also support Nix. But what if no one cared? What if nobody cared that you have problems or you like Nix? Well, then you end up here in this presentation. So where are we exactly? Well, there's a whole lot of user installed junk. There's a post which accompanies this. I'm not going to get into all of that, but the basic concept is do something to get Nix to build. Anything, unholy things to path, prune bits of the source code, just get it to install somehow. And then let Nix reinstall itself, right? So I'm not the first to think of this. There are these two excellent repositories which I liberally looked into when I was doing this. And unfortunately, none of them are up to date, hence. So, are we done? Is it over? Well, no, even for the short presentation, there's still a lot of time, so not quite. So what went wrong? Well, if you follow along the methodology which I covered in the post, then, well, you basically, because it's, you can't utilize the cache, and you're basically running on the login node, and you're wasting a lot of resources. Yes, these resources can be tracked down to you, you can be censored for it, so, in that sense, you're still responsible, but, it's not great, right? So what do we need, really? We need better permission handling. There was this incredible moment when the permissions were so poorly set that you actually have to run a little watch command, which is terrible. And of course, nobody should be 777ing their permissions, but still. Okay, so there's another issue, which is that the lock is not necessarily released at the same time, especially when you're building a large package. And one of the quote-unquote fixes is basically moving the package, moving the entire directory, and then rebuilding it, which is clearly not ideal, right? So where are we really? Well, builds and queues, we need to know who's building what, and we also need to be able to run on the entire cluster, not just the login node, right? So future directions, there's the union mount proposal, which essentially is meant for efficient private stores, but it's a step in the right direction. It would reduce compilation. It doesn't actually replace the global store. There's a discussion here on Reddit. And my own personal goals, like what do I want to do? Well, I was thinking of looking into hashing relative to a prefix and a cleaner setup. Definitely, it is not, I mean, it's a long blog post and it is not pretty right now to do this. And hopefully I'll be back next year with a more complete project, really. I mean, with more information and with a better approach to this. I have a couple of years on my PhD and I plan to use Nix exclusively, so yeah, I'm definitely going to be looking into this more, so yeah. That's the end. Well, not exactly. There's the bibliography, and thank you. Thank you for your attention.
Okay. Next up is Ryan Mulligan with Home Manager Template. So this is his project, which provides a quick start template for using Home Manager in a more reproducible way, so you don't have to install Home Manager, and it uses pinning, I mean.
Hi, my name's Ryan Mulligan, and I'm going to talk about Home Manager Template. You can visit it at GitHub, RyanTM, Home Manager Template. Why would you want to use Home Manager first off? Home Manager lets you reproduce your config, your user configuration instantly on new computers and also on multiple computers, so you can have consistent configuration across computers. It also lets you leverage a common configuration ecosystem. So Home Manager maintains a set of NixOS-like modules that lets you use other people's work, and then it lets us have less duplicate work. What is Home Manager? Well, it lets you organize your home with NixOS-like configuration. So there's a file called home.nix, which is very similar to your configuration.nix in NixOS. And then there's Home Manager Switch, which is like NixOS Rebuild Switch for switching to a new configuration. It does not require NixOS. You can use it on Linux systems, any Linux system, to configure your user environment. All right, so what's Home Manager Template for? It's for people that are allergic to installation instructions, people who don't like state, and people who want maximum reproducibility. So let's get into the details about how you can use it. All right, so yeah, what is Home Manager Template? It's a template file structure that basically it's just a Nix shell where Home Manager is installed and all the dependencies are pinned, so you don't need to install Home Manager. All right, so here's how you use it. First, you install Nix, then you go to Home Manager Template repo, and you click Use this template. And then you clone your repository onto your computer that you want to configure. Then you can update the dependencies to the latest version by running the update dependencies script. And then you can edit home.nix and then switch to your configuration by doing switch shell command. All right, so here's an example minimal configuration that you might have when you start out. So first you need to specify your name. This is a Nix file, and your home directory where you want to configure, and then the state version that you're currently on for Home Manager. And then you need to specify that Home Manager will manage your shell. And this is necessary with Home Manager Template because it doesn't install Home Manager. So you need to have some other hook into Home Manager's hooks. And that one way to do that is to have it manage your shell. And then you can install various packages. There's lots of other configuration options available in Home Manager, and they're available in the manual. So after we have this home.nix file created, then we run switch. And then in my example, I have installed the package cowsay. So we can say, now we have cowsay available. We can say, hello, NixCon 2020. So that's the very basic, quick overview of Home Manager template. It's a very simple wrapper around Home Manager, so I recommend you check it out. It's very quick to install. And then also check out Home Manager, which is a great project. And the manual for Home Manager has all the details about additional configuration options that you should use. If you'd like to look at the slides for my talk, they're available here. And you feel free to email me with any questions you might have or any comments you might have. Thank you very much for your talk. Thank you to the organizers and all the attendees.
Next up is Eva Straka, host a DevOps exam using NixOps. It's about how to host a DevOps exam It's about how to post a DevOps exam consisting in deploying a Bastion host and a KVM virtual machine per student in order for them to deploy a website which will be auto-validated.
You're live.
Exam using NixOS. Sorry for my French accent and my hoarse voice. I just recovered from a COVID week. We'll show you here how with Ryan, which co-authored this talk, and we'll also speak today about NixOps for Proxmox, how we deploy Bastion host and a KVM virtual machine per student for them to deploy a small app, for example, in this case, a website, which will be at the end auto-validated. More precisely, we ran it last June with 70 students simultaneously. To test the ability, we offer 3 different levels of difficulty, which different secret for each student to avoid treachery. Exam subjects are generated with LaTeX, but that's not the point of this talk. In this talk, we'll show you how we set up the infrastructure on which students could log in and how we did it completely declaratively with NixOS. A little disclaimer here. To be fair, what we write in the short deadline context of university exam was a bit incomplete and experimental. For example, no student tried to perform the last level of the exam. Now I want to directly show you some part of the code, which you can also find online on git.newtype.fr/event/DevOps exam model. Here was some of the different files we use. I will not go through all of this during this talk. I will, for example, pass on the content of kvm guest.nix, which is quite straightforward and do exactly what you can guess, which is to create a kvm guest. The idea here is to show you how simple it is to turn student data into a working configuration. I will begin by showing you the short Python salsa in generate setup.py that generates some Nix code, which is student setup.nix, that will be used later in our configuration file, which is student.nix. So let's start with our bash deploy script, which is quite simple. Deploying our service is easy thanks to NixOS. You can see that we just rsync all our Nix file on prod and NixOS rebuild switch. And before that, we run the generate setup.py, which is an extract here. So this script will produce as a out student setup Nix from a CSV file containing the matching of student mail and username and the folder in which students have to send us their public SSH key, the read key function here in this code subset, the WireGuard parameter function called WG, GenKey, and PipKey in a subprocess to set up the WireGuard key pair for each student, and it relies on xx.py that exposes the py2nix function, which is pretty handy and lets us turn a Python dict into a Nix expression. Here is a random example of what looks like one entry of the Nix output that will be built later on prod. The student chose Debian as the guest OS for its deployment. NixOS was left as an alternative choice, but to be fair, we didn't test it yet. And this is an extract of student.nix that imports the previous configuration file, which is generated. The idea is to map attributes over the student to declaratively create KVM guest, and with the same idea, populate the right networking interface, networking host, networking WireGuard interface peer, or service engine virtual host, or security administrators, everything you need to make it work. To sum up, what we can ask, what are the benefits of this approach versus another one? I would say NixOS make it possible to have a quick and easy iteration in our development process. For this kind of projects, is pretty handy. 5 minutes was a bit tight, and Ryan and I are of course available for answering questions on any detail of what I just not take the time to present.
Our final lightning talk is Meet Nickel, Better Configuration for Less by Yam Hamdawi. And if I have mispronounced your name, I apologize, and you can go ahead and say it afterwards. And the topic is Nickel language aims to generate other general configurations that are not packages. And I believe our moderator is going to link the source code if it's not actually in the slides.
Hello everyone, I'm very happy to be here for my first NixCon. I'm a software engineer. I'm working on a project at Twig which is called Nickel, and I will talk about it in this talk. So I just recently dove into the Nix world, and it's quite an amazing piece of software. And in particular, I was struck by the power of Nix expression, right? Nix expression, first, it's a proper programming language, which is not always the case if you have had to deal with horrendous YAML templating language. You know what I'm talking about. And it's also a simple language. It basically JSON plus functions. And yet, it is a powerful one, because JSON plus functions allow you to encode quite a lot of patterns and idioms in it. And I've heard some Nixers tell me that they wish they could use this for something else, to generate not only packages, but other configurations, or even small per project scripts. But as Elko pointed out in his first talk, there are some shortcomings in the Nix expressions. First one is a discoverability and extensibility problem. By extensibility, I mean overrides, overlays, all this kind of stuff is really complicated for newcomers. The lack of types that already had been discussed quite extensively. And these 2 points are more or less addressed by the NixOS module system, but it's not a language feature, it's something external, which has some drawbacks. And finally, it's not really a flaw in itself, but if you want to use Nix on something else than Nix, you have to be able to evaluate Nix expressions outside of the Nix world. And it turned out that in practice, this is not something trivial to use in the Nix expression for something really unrelated to Nix. And so from there, this project started, which is Nickel, configuration language. And we have somehow 2 main reasons for doing that. The first one is to detach Nix, to make a spin-off of the Nix expressions language, but which is not dependent of Nix. And the second direction is to be able to explore and experiment with what could we add to this language for it to be able to do more stuff than Nix, or to overcome some of the shortcomings I talked about earlier. So this Nickel language, it has a Nix-like core, I would say. So same thing, lazy JSON plus functions. Try to retain the simplicity and the beauty of the Nix expressions language. And also we add some typing. So static typing is a bit of a heavy thing for a configuration language, right? You don't want to write and to statically type all part of your configurations. And so gradual typing allows both static typing and untyped code to coexist. But even if you don't want static typing, you may want dynamic runtime checks, which is what is done, for example, in the type checking of the NixOS module. And contracts allow you to do that, so to verify things at runtime in a principled approach. And it also has a merge system, a merge operation, which allows you to combine records or attribute sets in Nix. And the idea is to be able, more or less, to fulfill the same purpose than the NixOS module system, but with a curated set of native features of the language, rather than the external library. Right, so there is more, but it's a lightning talk, so I can go on and on. I have to warn you that the project is still experimental, so it lacks good syntax, it lacks a JSON backend, so it did not yet generate configuration. But most of the things I talk about and the design and the core language is actually implemented. It just lacks the last layer of paint to be able to actually use it. But if you're interested, please check out the repo, see the README, or just watch from distance what will happen in the, I don't know, next month, maybe. And that's all. Thanks.
Okay, thank you to Eva Straka for their talk. So that concludes the lightning talk section of the conference. Thank you all for watching those lightning talks. I will apologize if there was any sort of confusion or like delays, because we had a little bit of internal difficulty with organizing these. And I also believe we finished early. So our break will be about 10 minutes, and we'll be back for our next talk at the 40-minute, not the 40-minute mark, the 30-minute mark. Okay, see you all soon.
Oh, I forgot I wanted my camera on.
Oh, right.
I turned it on. Hopefully it's...
Okay, our next talk is NixX IPFS by John Erickson, and the topic of it is that IPFS is a natural way to distribute data for Nix because of their shared focus on immutability, content addressing, and decentralization. John and the team at Obsidian Systems have spent the past several months integrating the two, and he's pretty excited to present what he's been working on and what can come next. And a little background for this talk is that John has been using Nix since the summer of 2014, and he also heard of IPFS that very same summer and imagined them being integrated together. And he's been using Nix at work since joining Obsidian in 2017. Okay, John, take it away.
Great. Thank you so much, World of Peace. Wonderful introduction, and I am indeed quite excited to be here. In fact, I made far too many slides for my 10-minute slot, so buckle up. We're just going to try to get through them all. So that means I did have to narrow the scope. I'd love to talk about both why we're doing this and how we're doing this, but I'm going to focus on the how today, with the idea that not that many people actually contribute to Nix itself versus, say, Nix packages or other projects which are best in class for outside contributors. So hopefully that's still interesting, and hopefully seeing the technical details, you all can put together the big picture of why I think this is so important. Yeah, and without further ado, let's go. So Nix and IPFS. First of all, what is IPFS? I'm sure many of you don't know. To me, as a user, it's really quite simple. You can put data in and get a hash out. You can put a hash in and get data out. And IPFS understands references to other data within that data. So here I have sort of a compound object. And in the second case, I'm indexing to get this thing within the hive field. And there's my original object with its original hash from before. This type of reference is called an IPLD link. The data model for IPFS is called IPLD, hence IPLD link. And it has this sort of Big Ten approach of there's other content addressing ways out there. Let's try to support them all and get as many people on this IPFS bandwagon. And important for us, those other approaches include GITs. And really, as a user, I think that's all you need to know. It's really ironclad. You know, due to network issues and other things, you may not get the right you may not get a response back, but you'll never get the wrong response. So putting and getting, that's really all there is to it. Next, let's go inside Nix. Nix has an architecture something like this. There's some utils at the bottom. There's some new stuff like flakes on the top. But sort of three core libraries are the store, the fetchers, where all the built-ins fetch. This fetch data is implemented, and where the expression language is implemented. Today, we're going to mainly talk about the store, the heart of the beast, and also a little bit, tiny bit about the fetchers. So first, some data types in the store. We have the store path. I'm sure this all looks familiar to you all. There's the name part. There's the hash part, which is really quite a mess. And actually, we don't store the store there. We get it from the store that we also have a reference to internally. Store paths can be made two ways. They can be input addressed, in which case we are hashing. Sorry. The input address means this inscrutable bit becomes from how we are deciding to make the path, versus content addressed comes from how we are what the data is itself. And the reason I call it inscrutable is if you have a provenance, you can check if store path matches it and verify the provenance, but there's no way to invert the hashing functions and derive the provenance from a store path. Store path really is quite a bit of a black box. Oh, it looks like I have more time, so I can slow down a bit. Next up is the derivation. These are the nodes in the dependency graph. I have a fake dependency graph here. They have fields like the outputs. These are the paths produced. The builder, which is the command that ultimately is going to be run to do the work. Input sources, which will be used by this build step, and other input derivations. So previous build steps whose outputs we want to use as inputs to this build step. This is probably the most important data structure to what Nix does. Many other things store files, like I talked about with store path, but the idea of this broken up into steps, which are run in sandboxing way of doing the build plan, that's quite unique to Nix. So definitely keep the derivation in mind. Outputs, which I mentioned before, were previously represented with a struct like this. We have the path being produced and the how shall go on the hash for fixed outputs, but you'll notice these are strings. That's not really good type. I don't like strings. I hope you don't like strings. So yeah, just to have a nice workbench to add these new features, I wanted to clean this stuff up. So we did. And now it's something more like this. We have an explicit optional here indicating that actually those strings can be empty. And a struct that looks something like this, with the hash now having a hash type and the method for how that hash was made. One thing interesting to keep in mind is this corresponds to the type of derivations we have. You should be familiar with at least the ones we have currently today, which is the input address derivations and the fixed output derivations. So one ramification here is while fixed outputs are only allowed to have one output, and also the purity versus impurity choice must be made derivation wide, some of the other stuff could actually be decided on a per output basis if we wanted to. We just haven't done that yet. You'll see there's this other file ingested method type I sort of glossed over. Previously, there were just these bool recursives that indicated whether to use nar or just have a single file hashed atomically. Now that's also been replaced with this file ingestion method that makes those two options clearer. And likewise, where it was a field outside the derivation output struct, it was usually called just recursive bool, and now it's called method to put flat and nar on equal footing. We should probably rename recursive to nar yet, but clean up for another day. And lastly, there's valid path info. In a local store, so on your machine, this would corresponds to a row in the SQLite table. In binary cache, the types we have today, the HTTP-based ones, this corresponds to the nar info file. That is the first thing Nix will look up. And again, there's this string type here for CA. What's CA? What's the string? Not really clear. Okay, that's more clear. Again, it's optional. The string can be empty, and the CA is a content address. This again corresponds to those input address versus content address fields. If you have a content address one, it will have a hash, and that's what this is, along with how the hash was made, just like one of those file ingestion methods, and also something for the way derivations are hashed. I should also talk about the other stuff here. So there's a path itself. This is really this is the primary key, and this is sort of the other metadata for that path. So I probably actually want to split this out to separate the keys and the values. We have the nar hash, because even if you have another hash today, Nix always wants to also have its sort of native way of verifying data, the nar hash. And we have the references, which are the other store paths that this path may refer to. So yeah, all these structs we've gone over so far are the core building blocks of how libstore is put together. I guess the last, there's the stores themselves and a very big interface there, but I'm just trying to go over data, not interfaces. If you're the type of person that thinks they're different, unlike C++. Okay, so the first thing, now we get into the new features we have. The first is a floating content address derivations. I'm going to be really fast here because actually Regnet, the person who wrote the RFC for this, did a lightning talk. So scroll back about an hour or so in the live stream, or once it's chopped into talks, and you can hear more about that there. Really quick, today we have the regular input address derivations and the fixed output ones. There's different trade-offs. One makes input address outputs, the other makes content address. One works purely, one works impurely. One has floating content, which I picked the word floating because it's sort of the opposite of fixed, which is to say that until you build the derivation, you're not quite sure what you'll get. The other is fixed because we have that hash written down. Only one thing's allowed to be produced. For at least the IPFS purposes and not the other benefits of CA, all you need to know is that we have a third type, which combines the aspects of these. It's pure, it's floating, it can produce anything you want, but the output is still constant addressed. And so the short story is this should be purely better than the input address by sort of getting stuff from each and being the best of both worlds. Though you will probably want fixed output ones for those impure things. Making the new ones impure would not be the best of both worlds. And going back to our struct derivation output, now rather than just using the optional file hash to indicate the two types, we have all three. This is a sum type, or the rest is known as the enum. Never mind the wrapping struct, never mind all the names, but every type of derivation corresponds to a type of output, and they have or don't have information like a fixed hash, a way of hashing, or a pre-computed path based on whether that fits this feature breakdown. So I've talked about what this is. I haven't talked about why we need it for IPFS. Answer is pretty simple. More content addressing is better for IPFS. I want us to be able to do arbitrary work in Nix as we do today, but have all the intermediate results content addressed for better interoperability with IPFS, and that's exactly what derivations, CA derivations give us. The next feature is Git hashing. In case you follow how Git works, this is tree and blob hashing. How the files and directories are hashed, not commit hashing, since nothing in Nix's data model worries about actually storing commits and storing history. So implementing this after those previous refactors was pretty simple. What the change in the types, we just add a new variant to this file ingestion method and fix all the errors. So the benefits of this is first that our fixed output derivations no longer need to have this SHA-256 that's totally unique to Nix and meaningless to everyone else. You can actually get the tree hash that one could use directly from Git and put that in your derivation. So again, trying to interoperate with the rest of the world a bit better. Also, the built-in fetchers, we've also given support so they can work not just fixed output derivations. And finally, like I mentioned before, IPFS supports Git hashing out of the box. So this means that we can go from store paths made, content address store paths on the Nix side made with the Git and IPFS references are one-to-one. We don't need to know what the data is. We can just convert the reference itself. And this means the whole process is trustless, which is really good. The next feature is content address-based queries. Yeah, like I mentioned before, the store path is opaque, and this isn't so good when you want to query something that doesn't know about Nix, doesn't know about store paths, because it can't really do anything with an opaque query key like a store path. So we made this new type, store path descriptor, which has a name, has the content address, and has references. And this, just to be clear, is exactly the pre-image of how CA store path is computed. So this is now the provenance reified, and this is something you could verify a store path with. And also on the valid path info side, something that store is supposed to provide back. Oh, I actually messed up my slides. This field is supposed to be gone because we now have collapsed the nar hash and the CA into these data structure, where these is a Haskell idiom I rewrote in C++, or we did actually, coworker and I, where you have one, you have the other, you have both. So the idea here is Nix no longer is so attached to its nar hash way of verifying data, and instead just any sort of hash will do as long as there's at least one. You can still have both, so there's no loss of information, but Nix can make do if you just have the constant address one from which the path is derived and not also this additional nar hash. So using these new types, we can change the store interface, which I won't get into the exact methods, but I will describe what this abstractly looks like. Before, we were always querying with store paths, and if we were trying to query about a path, we always got path info with the nar hash. Now you can query with the store path or the descriptor, and the info only needs to have at least one hash, not both. And what this means is we can use IPFS as a substitutor or binary cache, and there's no extra metadata, extra trust, extra signatures. You don't need any of that. If you just want content address data, you just get content address data. There's nothing to set up or worry about. So this is a big usability improvement, especially if we want to distribute source code versus binaries over IPFS, which I do. And so the next feature, this is, so far we've been kind of getting the kind of core stuff for working with existing like Git data and IPFS. Now we'll get into sort of the more IPFS specific improvements. So if you remember from before, store paths can have references, but references are very much Nix concept. Git's data model doesn't have any sort of store references notion. So if we want to do arbitrary data in Git, we can't just use Git's tree and blob hashes out of the blocks, but need to add this other information in. So we made this Git with references convention. I have what's probably a really blurry example for you all here, but we can just go over the highlights. This right here is an IPFS link for the actual file data hashed normal Git way. Next, we have the name. And we need the name for any self-references. So we're using Nix's existing ability to zero out the self-references, but we need to fill them back in. So we need the name for that. And the references themselves, rather than being store paths, are IPFS links to other data with metadata that's encoded the same way. So the reference graph is now an IPLD graph of everything we need. And the last feature is IPLD derivations. If you have a derivation that kind of uses all the new stuff, it's floating content address, its input sources are only get with or without the refs as just described, and the input derivations are only such other derivations. So it follows these rules all the way down. We can convert that derivation and its dependencies to IPLD. Get blurry example, but we've got the links to the input derivatives, links to the sources, and so that's it. The whole graph natively represented in IPFS in a very, I think, intuitive way. I hope you do too. Last feature, which we didn't do, is storing the map from the outputs to the hashes in IPFS. So again, basically at time. So this is because there's one trustful part still left, which is when we have builds that we don't know what they'll produce, there's no way to verify that other than doing the build. So if you're going to use any mapping at all, any sort of cache, you have to trust the cache. And now we can put this all together. So with all the stuff, all the changes we've made, we can have all data content address, be it sources, build artifacts, or the build plans. That's the derivation graph, the last implemented feature I talked about. We can use the same content addresses end-to-end, whether in IPFS or Git, because the way we wrap them and the way we did IPLDs, so the way we wrap them with the Git references, we can still convert that to a likewise calculated Nix path. All just obtaining the data, never mind why, is completely trustless because it's the same content addressing moved throughout. And only this last bit, the mapping from derivations and outputs to the hash of the data actually produced, is trustful, and that's okay because that is inherently trustful. You're trusting another binary cache to say what the data is and trusting what it purports to be. Okay, so still pretty quick, but that's my last slide. Ready for any questions? Hope that made some sense.
Yep. We are into the Q&A portion now, and I will read you off the first question. So this is from another speaker we had yesterday. Is it feasible that IPFS support the Nix packages scale at some point? How much time do you think it will take to reach this level of maturity? I hope that made sense. Some part of that seemed a little bit disjointed to me.
I certainly hope so. I think the question's a bit vague for me to really like.
Okay, we can move to the next one. Okay,
Yeah,
so what does CA derivations with contents floating mean?
So the CA is content address, which refers to that the output paths are content addressed, not input addressed. So the type of store path you get. The floating refers to that there is no fixed hash, and like a normal derivation, it can produce anything it does. That's why it's pure. And then it's a derivation because it's a derivation. I think that's all the words in the jargon.
Yep, it seems there's an intersection of a couple concepts like floating point numbers and like CA certificates.
Oh boy, I didn't even think. Yeah, it's nothing to do with either of those.
Right. Because content addressed and those are like almost the same.
Oh yeah, well, we're gonna have to get rid of all the CA and go back to content addressing, so no one thinks certificate authority. Good point.
Right. Okay, next one is there hash type whitelisting?
Say that again.
Is there hash type whitelisting?
I have no idea what that means.
Okay, I will look in the channel for any other questions like people clarified, like after hearing this, like if they want to elaborate or something. Hopefully, I think the stream might be for like 10 seconds behind for some people.
Okay.
Okay, I do not see anyone elaborating. Oh, I do see someone typing. Okay, I had Nick ask, what do you mean by hash type whitelisting? And I see someone saying, if you're only storing git tree/blobs, how do you go from git commit or git tag GPG signed to an IPFS entity?
So the IPFS does have a way of storing signatures to sort of deal with mutable data, like what's the latest release. And I ultimately would hope to use that. But for the time being, that's just out of band information that we trust the person to put the stuff in Nix packages is going to dereference those stuffs correctly. So no worse than today, and future work I'm excited about too.
Okay, I did see, hopefully this is a little clearer. They said something like being able to use arbitrary hash types now. That was the one that needed to get some clarification. Does that help at all? If not, I can just continue.
Oh, I think. Oh, so the idea is not that there's something called a whitelisted hash type, but we're whitelisting the hash types. Well, they've always been actually a whitelist in Nix. I mean, in that there's like a hash type enum, and you have to pick something within there. I guess over time we can just support more and more, and I think that's generally good for trying to interrupt with as many other groups of people as possible. But we should be mindful of not overly reliant on SHA-1 and other ones which are no longer terribly secure.
You have that absolutely right. Not secure at all, actually.
Yeah, well, if I may, I have raised some ire by saying we should continue using Git hashes for the time being, despite the SHA-1. But I think Git's SHA-256 stuff is around the corner, and so given the other people using SHA-1, we can practice interop with them today and practice crypto agility, all switching away from SHA-1 together tomorrow.
Right. That sounds like a logical course of action. So another question is, would IPFS give quicker substitutes than usual HTTPS on Hydra or similar?
Honestly, Amazon's a big company, and so if it really depends on the load. In the short term, I don't know, probably not. But if you imagine a super popular Nix, and we're not just wanting to shove out more and more money via the foundation for S3 or whatever, the CDN aspects of IPFS could really flip that. So it's a type of if you really believe in the premise and you're not just focused on the benefits today, I think there will be an inflection point and it will save resources in the long term.
Right. And I think, so a follow-up from the question, it says, if you're only storing git tree/blobs, that one?
Okay.
Yeah, so as a follow-up says, so a trusted human would need to resolve git commit hash to git tree hash?
Yeah. Just as a trusted human needs to write down that SHA-256 today. Yeah, that's just the same mediocre situation. But again, if we so if we do all this, it's actually a small step to say derivations can produce arbitrary IPLD data and not just files. Really, the core idea of the Nix is that we're sandboxing the build step, not that it needs to consume and produce files. So it'd be actually cool if we did download all the history and then we had a, trustless way to traverse the Merkle tree as exists mathematically. And then we could really write down the thing people actually know about and not have this human writing stuff in Nix packages, trust them step anymore.
Yep. And I think, to be honest, I'm not sure what schedule is because we had to change durations. So I think we'll just do one more question.
Sure.
So this is from Hyperfect. They said, as far as I know, currently a NixOS Foundation maintains a mirror of tarballs used in builds. Are there any plans to have fetchers in Nix packages that can fetch from a normal source by default and fall back to IPFS for a chance at long-term reproducibility?
Yes, that's exactly what I want, because IPFS is just a substitutor. You already get that. Nix will in general prefer substitutors to building the derivation, and that includes fixed output derivation. So that's exactly the plan. Also, I might add the tarballs.nixos.org type of situation. We we could make a hash mirror store based on that hash mirror concept, where even without IPFS, we just look up the constant address rather than a store path, and then this allows you to use that same information even if you're not using /nix/store, which you could not do cross store dir substitution today as easily.
Great, great. So I believe you're out of time, so let's get to the thank you. Thank you so much. I really, really enjoyed your talk. Your Q&A session was quite fun, and you also handled those questions as they came in basically live really, really well.
Well,
And I'd also like to thank you
you.
personally for all the work you do inside Nix packages. A lot of what you do just goes right into there.
Well,
So that's
thank you
really
so
cool.
much for all the piece. Yeah, it's certainly good to be here. And honestly, I feel like I rely so much on people that do the real day-to-day maintenance of Nix packages, which I don't. So we all depend on each other.
Right, right. You have that exactly perfect. Yeah. Thanks. So everyone, I did mention in the chat that we had a scheduling issue with John's talk, as you've noticed. So the next talk, I believe, will be starting pretty much as soon as we can because of that. So I will get back to you in a moment. Okay, we have NixOps for Proxmox by Ryan Laffa. And in this talk, we are going to explore how to build and manage dozens of NixOS virtual machines in a Proxmox cluster using NixOps in declarative fashion. And a little bit about Ryan, if you're not familiar, he has been a FOSS developer for more than 5 years, and he is a student in mathematics and computer science. And he enjoys playing around with like infrastructure, and he runs his own micro data center using NixOS. Okay.
Hello everyone, I will introduce you to NixOps for Proxmox, which is a plugin for NixOps using Proxmox. So first we will see what is Proxmox, what is NixOps, and what are backends in NixOps, the actual Proxmox backend, the challenge I encountered writing this backend, and what can be built on the top of this, and what can we learn from this kind of experimentation. Finally, there will be a demonstration showing how to deploy ser.ht on your own infrastructure using a Proxmox and NixOps. So Proxmox is a distribution made to deploy virtual machine in containers. It's using KVM and QEMU, and it comes with a nice web UI and API command line. It handles for you a lot of details that you don't want to deal with, such as storage backend, multi-clusters, and it's being actually used in production on real-world deployments. As for NixOps, it's a Python application that enables you to transform Nix expression into reality. So that means that, for example, if you read down what is supposed to look like your infrastructure, and you have the right backend, so a plugin that implements the right API call to transform Nix expression into reality, then NixOps will ensure that the reality will match what your Nix expression describes. That's the theory. In fact, it works pretty much well, not really good at large scale, but it's super interesting. One of the things I like about it is super modular, meaning that you can read down backends for whatever you want as long as you have an API or something like that. For example, there are Amazon Web Services, Google Cloud, Azure, Edge-Null, libvirt, VirtualBox, and it supports trivial NixOS machine with an SSH server. So a backend is basically a plugin in NixOps that implements a certain part of the NixOps interface and bring a definition, so think a Nix expression, think an expression of a resource like a disk into reality. So if you had a disk in your definition, the backend will be responsible to bring this disk into your infrastructure by creating it, then attaching it to whatever resources you have that mention this disk, and doing a lot of things on it depending on your actual implementation. For example, here I'm taking a simple Amazon Web Services NixOps expression, which deploy a machine called machine, and it's deployed in a certain region and for a certain instance type. So it imports also information about my Amazon Web Services account. That's the ec2-info.nix. And what is interesting is that if you build on the top on this Nix expression and then someday you say, oh, I need a beefier machine, you could just change the instance type, right? And everything would work more or less fine. So that's an interesting thing. Well, other software implements it also in the Nix ecosystem. But actually I'm going just to use NixOps. And Proxmox. So I start from the fact that there are no actual real backend for private infrastructure. libvirt is not enough on its own because it doesn't implement as much things as Proxmox does. So after some time of installing NixOS manually using the live, I decided to write down a NixOS plugin, which made sense, and I wanted to validate if it was the right idea and if NixOps was flexible enough for my use case. And actually, it feels a bit like Amazon Web Services, with a lot less feature, of course. But it has this nice property of being a bit declarative and being able to map over machines and deploy them automatically, etc. So I think in my opinion, the experiment is a success because I really want to extend this plugin and go further. And that's actually possible thanks to modularity of NixOS. I will just outline for the talk how the plugin works. So it's not super perfect, it's of course, but basically it just creates what it needs to create first, so disk, then virtual machines, then it will attach a CD-ROM at the same time. It will wait for QEMU agent to be up. So QEMU agent is an out-of-band communication mechanism that you can use even if you don't have networking yet at this step. So that's super useful because I'm not sure that I can have DHCP giving me IP, or I can even route some packets to the virtual machine. So using this agent, I can provision SSH key, prepare the machine for receiving NixOS on the disk, doing the partitioning script, and generating an initial configuration.nix before the actual installation. Then I will check if after the install everything is fine, and if everything is fine, I will mark it as installed and give the job back to NixOps to do its magic. So that means that NixOps will now assume that the target is a NixOS machine and that it can be provisioned like a NixOS machine, so sending some closure and switching of configuration. And also secret sometimes, there are more details, it's not that important. One of the challenges I encountered was that NixOps has no real support for IPv6. So at the same time, as it was super modular, I could just bake the IPv6 support in my own plugin, and this is what I've done. So it looks like this. I just get some interfaces with our IP addresses from the QEMU agent, then I just do iteration over it, filter for the private IP, the public one, the v6, the v4. I exclude the link local for IPv6 because I don't want to use them, but it could be used. And then I take the first reachable, or I don't. That's interesting because it brings me to the next challenge I encountered, which is how to select the right endpoint. If you have that many addresses, how do you know beyond the reachability criterion, how do you know which one you choose? So I listed two scenarios that I actually encountered in real life, and personally I decided to fix this by saying I always have IPv6 on my machine, but that's not an acceptable fix. But at the same time it was interesting. I think that research have some algorithm on that. You want to optimize your endpoint based on multiple factors. For example, you want that an endpoint that is fast, an endpoint that is reliable, and an endpoint that is of course reachable. So that's interesting. I didn't implement the whole solution, and I'm still looking for an implementation on that. And my nemesis currently is partitioning. So partitioning is not declarative in general. In the installer, you have to do your partitioning yourself. There are actually some software that can help to this. Hetzner is using NixPart, for example, the Hetzner backend. But it's not that flexible for my use case, and I would like to have full I would like to use every file system I want. So ZFS is out of the question using NixPart, unfortunately. So I fell back on classical bash, but it's of course super error prone. It's not that bad, but I spend too much time reading the manual page and doing stupid mistakes. So I would like to get out of this model to do something better, and I will talk about it later. So the current state of the plugin is, it's of course buggy. It's not absolutely vaporware because I use it, it works, but it has to be a lot improved so that it could be used in production, for example. I listed some bugs that I'm sure exist. Some of them are trivial to fix, the state machine one, for example. But the most annoying one to me is I cannot use default NixOS images. And I'm forced to use a custom one which is provided in the repository because I need to enable QEMU agent. But if I find a solution for that, I could get rid of the default of the custom NixOS image. Other than that, it's really alpha quality, so you don't have backup, tag support, you don't have round and robin distribution on your Proxmox cluster, so you want to have like maybe equal repartition of all of your virtual machine over all your nodes. You could do it yourself in the backend, to be fair, so it's not a real problem. What I will look forward to would be to extend this kind of work to other kind of software that you can see in private infrastructure. Personally, I use ViOS, and it would be interesting to manipulate your routing routing in NixOS and acting on the top of it using API, etc. So that's an experiment I would like to conduct, and bring the routing table to the next expression would be really interesting, so that you could build some kind of DSL on the top of your expression, and then you can express a lot of things in a concise way, and changing one thing doesn't have to force you to find which things I need to change, etc. Because you can just propagate the changes automatically to everything that it needs. So that would be really interesting. Also, of course, I showed that I don't have declarative partitioning, but I want declarative partitioning. So of course, it's not a solved problem currently as far as I know. There are some efforts in NixPart. There is an interesting draft of the partition mapper in the wiki of NixPart, which shows how to transform if you have a file system into another, and how to emit the commands to migrate the things. So that's super interesting, because it means like you can do live migration, live changes to your file system. But of course it has to be in a secure way for your data, so I'm not sure on this point, but it's based on a library using by Red Hat people. They're using it in their Fedora installer, and it looks like pretty much solid, so I think it's interesting to pursue such a thing. And also, I require it because I would like to have automatic LUKS decryption and automatic LUKS encryption, which is the next point. If you don't have declarative partitioning, it's super hard to automate LUKS encryption, except by doing some scripts and stuff like that, but it's error prone, and it's bash, and passphrase management is not super obvious, etc., etc. So if we would have like secret management a la Ansible, a la Vault using by HashiCorp, and full disk encryption with declarative partitioning, it would be really trivial to add fully encrypted guests really easily with automatic decryption using Mondos. Mondos has an interesting threat model which is reasonable and enables you to decrypt machines at boot time using other machines. So it works by maintaining a table of PGP encrypted passphrase, and you send them the encrypted message by your trusted peers, and then it's kind of fully meshed, and it works also with a manual passphrase entry or whatever you want also. So it would enable full disk encryption into data centers, which is interesting. So to conclude, one of my personal objectives is to see more offerings of private flexible infrastructure like Amazon Web Services does, without having to use their infrastructure. So the thing is that you want to own your own physical service because you have some constraint and you want to run software in a nice way. So I think that Nix is an important key towards this goal. And contrary to NixOS, which is well known to be this old piece of software that doesn't work that well with everything the rest. But I think it's salvageable. The new version looks really promising, and it's not that bad. But of course, I can understand the criticism. Finally, if the future work that I presented could be implemented, it would enable a trivial, easily IPv6 only, NixOS only, fully declarative micro data center, which to me would be a definitely exciting first step towards independency from the public clouds. So that's something I'm looking forward to. And thank you for watching, and I will be available for a question over ERC2, and don't hesitate to watch the demonstration if you find this interesting. Thanks.
Okay, this will now begin the Q&A portion. So I believe we actually only have one question, and I think our presenter actually saw it as well. So I think we'll just rehash the discussion here. Do you think you could do that, Ryan?
Yeah, do you hear me? Do you hear me?
Yeah, I can hear you.
Okay, all right. So the question asked by Niku was, why not implementing happy tables for the IPv6 versus IPv4 connection selection mechanism? And the thing is that, so I think, I'm not sure I exactly talked about it in my talk, but you have multiple criteria that you want to optimize, like, for example, reliability. If your link is working well on the first packet you're sending, is it going to work well afterwards? Same goes for speed and reachability. So you have to take into account that you're sometimes roaming. So you could retry doing the happy tables each time, but I think it's a bit not efficient. I think there are algorithms in research that shows better results in terms of those criteria. So I think we have to implement and measure actually how it works really. So that was kind of my answer, and some people re-explained the same things.
Right, a little extra commentary.
Yeah.
So I think with that, I don't see any more questions. Yeah, I do not see any more questions. So I believe this will elapse the Q&A portion. Thank you for being here. Thank you for your recording. It was great having you.
Thank you.
Yep, and everyone go offer Ryan in the chat. Come on. And you also can be present into the breakout room, NixOS-Proxmox, to answer any more questions if there are. And yeah, we'll be going to a 5-minute break for our final talk of the conference. Okay, the next up, well, actually, no, currently, we have How Nix Grew a Marketing Team by Garbus. And this is about marketing, and non-technical work is all too often an afterthought for developers, or worse, is actually viewed as something like negative. So Rock really wishes this wasn't the case. Having clearly defined problems, audience and strategy should be as important to us as having clean and tested code. So, this is important for Nix, this is important for any project that aims to succeed. And if you're not familiar with Rock, he believes he started using Nix in 2010, and he is a senior engineer at Twig.io, and he did the first Nix sprint in Slovenia in 2013. And yeah, the head of the marketing team. So take it away.
Hi everybody. I hope you can hear me. How do I actually know? I don't know. It's not yet, because I don't hear you. Should I continue? Okay. Hi everybody. I think now you can hear me. Okay, so it's a privilege to be giving you this presentation, and I don't just say this to everybody. I really mean it. It's for a simple reason. It's because this concept of a family, belonging, a team, it's personal to me, and it's as much as it's personal to you. In past, I did presentation at meetups, conferences, and those presentations were always at conferences of other also great technologies, but it always felt this distance between what they do and what I do. So this talk is really special for me, and it's really special to me, and because I'm talking to an audience that is just like me. I feel home here. So thank you. So today I'm going to be talking about how Nix grew a marketing team. And yeah, I was always passionate about getting Nix in hands of other developers, other people, not only developers. So after I actually moved to Berlin for my first Nix job. This was in 2014. And after 1 year of experience of working with Nix, I wanted to do this more often. And I went to every meetup. I tried to talk to every developer there in Berlin, and that's a lot of them, and try to convince them to use Nix. I was, partially successful, but it always felt that this distance, as I was talking before. And for the reason, as it usually happens in Berlin, you go for a kebab with a fellow Nix person, and suddenly you end up organizing the Nix conference. So we organized a Nix conference, and why is that important? Because there I talked about making Nix friendlier for beginners. I thought Nix is great, already in the shape it was, but I wish I would be able to fix only a few things. And there were few things that I emphasized there. One was this first contact with everybody getting to know Nix, which is the installer and the website. So the installer and the website. Then there was the command line. I think I was a bit too harsh now rewatching the video of Ilko. And then also the documentation, right? So already back then, this was clear what we need to do, right? And I gave a similar talk in 2018 while I was working at Mozilla and trying to introduce Nix at Mozilla. And how I actually introduced it at Mozilla and what were the pain points. And I think what I remember from that talk was that at the end I said, if there is one thing you want that we should actually change, is actually the website. Because that was the main complaint that I received time and time ago. It all boiled down, it was not the only, but it all boiled down that either they didn't know how to find the documentation. So the website, this entry point, was always the problem. And this passion of me trying to introduce Nix to so many people, it got me into this really scary place. And some call it marketing, and I don't see it anymore as a scary place. But I've quickly found out that many, including my past self, have a very negative view of marketing. It kind of ranges from I don't care about it, and marketing is evil. And actually, this is for a good reason, because a lot of marketing is, especially the one we perceive and the one we acknowledge, is actually the deceptive one, or at least it feels that way. That's not all of the marketing that there is. It doesn't have to be that way. So it doesn't have to be this way. So in my past, I was, as I said, I was in the I don't care camp, where I didn't care really about marketing that much. But there was a moment which I want to share with you, which got me over, which started the process of me actually thinking a bit differently about marketing. And this was the moment when I encountered this number, and 59% is the percentage of our behavior that is controlled by our subconscious. And that fascinates me. It's not 20. I knew that there is some subconscious involved in our decision, but I thought it's lower. It's not 20, it's not 50, it's actually 95, and that shocked me. And this is actually this is applicable to every human on the earth. It's not something that it's only depends on where you're from or how good education you have. No, this forces that are in our subconscious actually come from evolution. So that's why it is global. And these forces we usually call human behavior. And it feels like there is this puppet master and we are the puppet. And that makes, and even when we die, our children come and this puppet master controls them, the same puppet master. And this is I felt very uneasy. I thought I'm a rational person. I thought I'm an in-control person. And that put everything that turned everything on the head. So, but on the same time, I acknowledge that this is a powerful knowledge. And, with everything powerful, you can use it in a good and a bad way. And marketing, especially the advertisement, I guess that's where the evil part comes from. They take advantage of this, right? And I said, it doesn't have to be evil. I'll try to give an example of good and bad marketing, or at least hope I don't mess this up. But let's say, you go on a first date. You don't put just the first t-shirt that you find. You actually put a bit better. You put something better on yourself. And you're trying to present yourself in the best light possible. And that's already some sort of marketing, so to say, right? Because you don't want to lie, you don't want to deceive, but you want to put your best. Because in our human nature is that we take the first impression really seriously. You know that if you are not, at least in school where I went, if you're not good in the first semester, this is where you get the label for the rest of the time in the school. So first impression is really important, and there are many more other human behavior things that we need to take into the account. And even before, I'd like to consider myself a problem solver. I'd like to see a problem and try to solve it. And the problem of adopting or growing the adoption of Nix was a problem that I couldn't solve. Like, how can we solve it? And this is one of the things that put me on the path of marketing. And many books after and many talks to people and so on. This led me this year to create a marketing team. I mean, I was only the person to announce it, and then others joined. But this was important because you cannot really do the whole marketing process by yourself. You need to be a team, especially if you want to do this in continuous way. So, but before we continue, that's actually really important. I'd like to also discuss what marketing is. Like, I know it's a bit of a going off the rails, but I think I didn't address what marketing is. And one of the many complaints I received when talking about marketing is that the language that marketeers use is unfriendly or very foreigner, right? So, and that is because a lot of resources that you can read on marketing, and there are many, are written in a language where they mention customers and sales and different things, but there are not many books written about marketing on open source. Actually, I found any. There are a few blog posts, there are a few presentations, but on this topic there are not many, or at least not specifically mentioning the marketing, but kind of going on, taking different aspects of it. So I composed few definitions, because there is also not one definition of marketing, but I took few definitions. I kind of tried to combine it, and I hope and translate it, of course, because I don't want to call our new Nix users customers, and I don't want to talk about sales. But for the purpose of marketing team, the NixOS marketing team, I think we can say that marketing is a non-coding activity that drives adoption. So everything non-coding that will drive adoption is in area of marketing, or it's touching the area. It's most likely marketing is not the only marketing team will not be the only person, the only contributor to this. But if there is nobody, like, this needs to be done. So I think this kind of answered, and that's also the reason why I give the marketing team the marketing name, because it's all about the adoption. And importantly, I'll say it again, there is a good and bad way how to do marketing. I don't want to deceive people. I don't want to put bad ads or things like this. I just want to give Nix a chance. I want to prepare Nix to dress well Nix for its first date, basically, right? So with that out of the way, I'd like to take you on a journey what we did in the last 6 months. So it's a bit more, but in the last milestone. And before that, I'd just like to thank that this was not only my work, but there was there is a team behind it, right? You probably met it if you followed our minutes that we try to publish as soon as we have the meeting and have the time to write it. But importantly, for each of these milestones, we have a certain goal that you try to focus on, and from there we define certain tasks. And for our first goal, so this was actually our our first few meetings was what are we actually going to do at marketing, right? And there were a few ideas thrown around, but our goal that we kind of decided on was we need to change NixOS.org. We need to make it look a modern and maintained project and ready to be used in production. And we kind of develop a three-step thing that we will follow. And first is we need to define, in order to do any kind of redesign or even kind of have any marketing talk, you need to know your audience and the use cases in case of the Nix and NixOS. And here I want to emphasize actually that we only define these primary use cases for nixos.org. Nothing changes in the code itself. It's only what we will put higher, or what will have a higher priority over other things. The next thing is, you cannot redesign if you don't have content and structure of the website. Usually this comes together. Although in our current case, where we are redesigning the existing page, we can already adjust the content with ideas that will drive the redesign later on. So we did that, and we redesigned. And the last step, which is still a bit in the progress, it's the redesign of nixos.org. So the actual writing the CSS. So going back to number one, what was this? Well, decided. So first on this part, nothing is really decided for a long term, which each year we will re-evaluate whether our audience and use cases are still valid and adjust. So one aspect of marketing team, we need to listen to everybody, and that's why we put all the minutes out, and we do listen to the feedback you give us. We might work on it a bit slower, in a different pace, in a different order, but we do listen to it. We do take it into account. So our primary use case that we put now was for Nix. We use the primary use case for Nix. So the main audience for the website is beginners and decision makers. So the one who decide whether the Nix is actually good enough to be used in their company. And the primary use case for Nix is development environment. Kind of to translate it to the Nix developers, this means Nix shell. Everything around Nix shell. I think it's the most polished solution that we have out there, and the most underrated that we don't promote enough. And we even have a talk. A lot of talks mention this, how great Nix shell is. And I think we need to, the website needs to reflect this as well. And the use case for NixOS, is cloud ops or cloud deployments, building cloud images, something along those ways, along those lines. And this will change, I am sure, but we need to pick one. And I think the building Docker images, building EC2 images, it's the most polished solution we currently have. If this changes, we're really all happy. Like, this is something that it's in flux. But this kind of drove the reorganization, especially the landing page, what's on it and what's not, what's at the top of other pages, that all drives it. And if you remember, and I welcome you to go on the Wayback Machine or timemachine.org, and look how the website looked in the beginning of the year, and then kind of fast forward to today and compare it. And I think the change is simple. Now, what we said in the beginning, and I was very cautious, is that we are not looking to do a perfect redesign and do a perfect change all the time. I think what's more important is that we do the change incrementally and always on the better, and eventually we'll get to the better place. And redesign, what was the goal of the redesign was achieved, because we didn't look for a perfect website, perfect design that will be always there forever, but we look for something that will look modern and maintained. And with the content, we are, I think, yet to provide the feeling that this can be used in production. But more on this later. So I think we are ending with the 2009 release happening soon. We are ending this milestone. And we mostly succeeded. I think we can still do a lot more on being more explicit that the Nix and NixOS is actually a tool that is being used in production, and others, visitor can also use it. So I'd like to look for the next period. Importantly here is that nothing is set in stone, because each half a year a group a bit reorganizes and people in the group decide what to work on. But these are some issues that we have in our bucket to kind of that we think we should work on. And the goal will be to make onboarding easier. Now we have a website, now we have a base, now we need to make the whole onboarding experience easier. And so one of the things is we want to serve fresh cloud images. So each successful evaluation should, NixOS evaluation should push the images to EC2. Not only fresh EC2 image, but we want to expand this to other cloud providers, especially the top 3 providers, let's say the Google, Azure, and the EC2, right? So at least that, if not more, why not? Because if we want to be seen as a cloud, really good for cloud, building cloud images, they should be easy to start, like we have now with the click of a button. There is another idea we have that, it's a clear idea that we need a language-specific tutorial. So on the Learn page, if a lot of people come to us and they, I want to use Python with Nix, how do I do this? There should be a visible on the Learn page, there should be a visible language. And there were many talks this conference on the Java ecosystem. And I hope this will, and what is Scala? So I hope, we need those instructions in one place and actually outside the manual, right? Geared towards the newcomers. Another idea is a prominent Docker support. This is more for the purpose of people trying it out. Using Docker as a vehicle, using other technologies as a vehicle to try out Nix will make onboarding much easier. Now, prominently, we can dive deeper after the talk why the current Docker is not good, but we need to make it easier to try Nix. And Docker might help us there. Oh, yeah. So I want to, my video is here covering this, but expose internal community communication. So all the teams we have, how they communicate, what they do. There are many minutes scattered to all of the places. Someone GitHub, someone, we want to bring them and help people who already started using Nix and want to contribute and give them the roadmap, how and where to go to find what's being in development currently in Nix, right? So what's the state of RFCs and things like this? What's been talked about? Next on the what, we want to have job section. I think Doman yesterday mentioned, this tricycle where you have the industry, developers, and everything feeds into each other. And I think having a job section will first make 2 things. It will make it easier for you to find the next Nix job, and it will also is seen very production ready, because everybody that's adopts Nix will also want to hire. One of the things I already started is actually gathering the success stories and white papers on, and I hope to do many more. And once I gather at least 8 of them, I will open this section on the website where people will see how Nix is used in maybe really obscure places, and how it's bending the what people think Nix can do. And then there is the commercial support. I think everybody will get stuck with Nix, especially in the beginning, and they look for companies to help them. This is, of course, can be a bit, controversial thing, but having a list of Nix providers that can help you, either personal or companies, in a fair way, and I think emphasis on being fair, right? So everybody should get the same space and so on. I think will address the production quality from the previous milestone that we had. So there is many things to work on, and not all of them are what you would assume are marketing. So building fresh images. There is some coding, although not on Nix itself, but there is some coding and working with infrastructure. So I would welcome you to join us. We are still open for another 2 weeks for. Something happened. I don't know what happened, but wait. Sorry. Maybe I need to I'm not sure whether you hear me, but I lost all the connection to the. But I'll try to go forward with the slides quickly through it. But as I was already at the end, so please join us. We are still open for another week. We only invite new people to marketing team for a week, for every end of each release. Ping me on IRC. I'm always Garbas on IRC or Twitter, or just I think also on Discourse. So on the end, I'd like to answer just this question: do we really need to do marketing? I think we do. We need marketing. Every successful project needs marketing. And if Nix wants to be successful, we need to do marketing. Marketing is a lot of work. It's not because it's hard, but it's, coordinating all of this, making sure all the images are there. So don't underestimate it. And with this, I'll end up. And I hope I see you.
Okay, it seems we only have one, and it's honestly just like a cheeky comment. I would say it's a good sign that you don't have many questions because you really were very thorough in your presentation. So, okay, I'll read this off to you. So how about planting a tree for each person installing NixOS?
Sorry, again?
How about planting a tree for each person installing NixOS?
I'm not sure this is going to help NixOS adoption, but if it does, let's do it.
Okay, so on that note, I would like to thank you. I really love the moment, like you mentioned, that we don't have control over like the subconscious. And like with awareness, you can use it to your advantage. Like I personally believe, like at least for myself, I have pretty good hold on my like subconscious communication. And you usually can sort of tell that by how people feel just by meeting you. So yeah. Like you
yeah, I find it actually a lot of times we think we do have control, and we most of the time make excuses for our subconscious.
Mm-hmm.
But it's good to be aware. I think this is always once you're aware, you can actually control it. And this field is just enormous, and I'm always impressed that I didn't know about it.
Yeah, throughout your talk, you basically guided us through a lot of your awareness on the whole situations and pulling that back into why a marketing team is necessary. So yeah, I would like to thank you for starting this initiative, the marketing team, and doing all this research and just really everything. Yeah, thank you so much.
Thank you.
Yep. Okay, everyone, I believe that is the last talk of the conference. Let me look at my schedule. I'm sorry. I believe we have some sort of like retrospective talk to get to, which is going to involve all of us as organizers. So I believe it'll be like a 5-minute break, and we'll get back to you with that. Okay, everyone, as promised, welcome to the closing portion of NixCon. And this is just going to be like a sort of casual sort of retrospective with some of the NixCon organizers that I have on stream with me today. And we're going to begin with the person behind the scenes making sure everything is working and stuff like that is Puck. So yeah, take it away, Puck. Go ahead and introduce yourself to everyone.
Yeah, I'm Puck. I have been using Nix for quite some time now. Before it was Arch Linux, and however many issues there are still in Nix, I cannot go back to anything else. And yeah, and I've been working to organize this conference basically from the start. When we decided to go, when Alyssa, like a friend of mine, decided to go, decided to write a proposal to make NixCon run online entirely on free software instead of depending on Discord. And now that it's basically almost over, we have done an amazing job at this. Yeah, we have been running this for, we've been preparing for quite some time now, and I'm very happy with how this all ended up running. Because behind the scenes, there's a lot more that most people have not seen, of course.
Right. You think you could also like maybe guide us through like the sort of technical details? I think that'd be kind of cool to talk about.
Most speakers who have been on NixCon have been using a Jitsi room, because we set up an entire Jitsi setup, including the bridge, which allows us to stream from Jitsi directly into the video switchboard, which is an instance of OBS running on a NixOS machine in the cloud to make sure it is nice and reliable. And we then transfer that to another machine also running NixOS, which then takes the video from OBS and turns it into the stream that you can watch from VLC, NPV, the web, and even YouTube. And this hasn't been without its faults. While testing this, I was at one point the X server that ran OBS just completely crashed, which is kind of an issue because that takes down the entire stream, obviously.
Right.
And thankfully, that has not happened here at any point in time. And I would like to thank, people that aren't here currently but have helped a lot. I would like to thank Alyssa for getting all of this running originally.
Could you mention Alyssa's GitHub name in like IRC Nix in case people are familiar?
Alyssa on IRC is QYLys, and on GitHub she's Alyssa, I believe.
Yep.
You've probably seen her around before in NixOS, the channels. And this all wouldn't have happened if she hadn't stepped in to help have NixCon run online. And I would also like to thank EDEF, obviously known on IRC as EDEF, for supporting me and Alyssa through all of this and for helping set up the initial infrastructure as well. And
Okay, I have a few questions for you actually. So I think this is one other people want to know is will the live stream be split up and when will it be on YouTube?
We will indeed upload every single stream, every single talk separately on YouTube at some point, and also even on. We've also got an account on a PeerTube server as well, so we will make sure that those videos will arrive there as well.
Oh, that happens.
It will take.
I didn't know that.
yeah, it just happened just during this conference, even during today. It'll be a bit. I think we're all like, we'll all be wiped out after this is done, and I am super happy with how this went. I am also very relieved that we don't have more days of live streaming.
You have that
And
right.
Indeed.
even today, even last night, the work hadn't stopped yet. Yesterday, me and Edef rewrote a bunch of the infrastructure to make sure that we actually have the capability to look back in streams instead of just being able to view the current live bits.
Oh, could you also talk about the live catch-up thing?
Oh yes, some of you may have noticed. I think yesterday there were a few people noticing this. Is that for some people the stream would like slow down a bit, like people would start talking slowly and then would suddenly catch up. And this is a super cool mechanism that is used to try and hide buffering. Basically, we're running the time for the stream to come out of the video switchboard and to arrive on your screen is about 10 seconds, and that is not a lot of time. And when your connection hiccups or something, you'll most likely suddenly have a lot less buffer to work with. So to make sure that you have enough buffer to run until the end, the software will literally just slow down the video a bit. And once you're done, once it has enough buffer, it will try to catch up back, so it ends up quite exactly to the 10 seconds from the video switchboard on.
Yeah, I thought that was super cool. It does like almost like a granular stretch.
Yeah.
Okay. So I think Nick, are you ready?
Yeah.
There's also one more question I saw just pop up on NixCon QA, which is, will the configuration for all of this become public? And the answer is, of course. There is a bunch of changes that I haven't quite pushed yet upstream, but most of the work we've done was in public on the NixCon GitHub under the NixCon video infra repo. We all have to tune a bit, but part of the design was for this to be reusable by other people as well that want to set up a conference of their own.
The video infra is way ahead on that. On the CFP side, yeah, I got a bit of catch up to do to upstream that.
Yeah, I really do
Yeah,
appreciate
we have a
that
few-
being reproducible.
Yeah, we have a few changes as well. We've used the Jitsi Meet pull request that wasn't quite that wasn't even upstreamed, like wasn't even merged the moment that we started using it. And I have a few other changes that I want to upstream, like the Jibri setup. But otherwise, it is very much going to all be open source. Obviously.
Yeah, exactly. So I guess that leads into you, Nick, our moderator and organizer. Go ahead.
Hi, I'm N Batham. So I'm kind of new to this community, I would say. Oh, that's my daughter. I kind of got into this about 4 months ago. I saw the discourse thread that said, well, NixCon might not happen this year. And I applied that internet principle that if you want to get the right answer, you first post the wrong answer. And luckily that worked and drew in Alyssa and Edef and Puck, and then World of Peace.
Yeah, that was such a great strategy.
Entirely by luck. And yeah, I just wanted to watch the Nix talks, and I'm looking forward to doing that next month.
Yeah, can you talk about a little more of your experience in the role for NixCon? Oh, I see you have some slides here.
Yeah, not slides as much as just some pictures.
Okay.
I'm very new to organizing, never really done anything like this before. So there's a lot of learning, a lot of mistakes made along the way. I mean, I went
Yeah.
through half a pad of sticky notes. What were you gonna say?
Oh yeah, I was saying most of my work as like MC was actually sort of working with you. You were immensely helpful towards me.
Well, thank you. I mean, yeah, I will thank everyone, but I'll also thank you, especially. You really helped keep the organization of things going and on track.
Yeah, for a lot of things you were very, very, very helpful, Rubber Duck. In certain instances. Yeah, I find that having Rubber Ducks are great to keep around sometimes, and you also were definitely more helpful than Rubber Duck, so don't take that as an insult in any way, hopefully.
Not at all.
Yeah. And I don't think we have any questions about your role for like as moderator. But I
Well,
will
I'll just share some random things for a second.
Okay, go ahead.
This is the inside of a big injection molding machine, which is relevant to my work.
Where do you work again?
I work for a company called RJG Inc. So we provide systems for injection molders and training.
Right, right.
And yep, this is my wife and my favorite vehicle.
Yep. And I think you showed some one already, actually.
Oh yeah, I don't have any other slides.
Okay. Are you okay with me? I'm going now.
Yeah, absolutely. First, let me just thank Alyssa, Edef, Puck, World of Peace again for putting up with me. And Zimba TM, Delman, and everyone else in the community for interacting positively, pointing me in the right direction. And yeah, this is a great community. Glad we can do this.
Yeah, absolutely a great community. So now it comes to me. So I would say I would like to talk about the things I just feel proud about. So I actually have never emceed anything before, like at all. Like I've done some talk stuff and like that, but I've never been an MC. And I would like to say that I believe, at least hopefully not like in a conceited way, that I have like an uncommon talent with I guess being talented at things I am not aware I am actually talented at. So one of those other things was like release managing NixOS. Like did not know I was going to be talented at that, but I ended up, I guess from the response I've got, being pretty talented at that. So yeah, I had an amazing time emceeing for NixCon this year. I really put my all into it, I would say. The first person who mentioned to me that I would be MC was Edith, and it was in a PM. And she told me that, she saw my stuff and like I believe it was office hours. And because I had experience with that, it's essentially almost the same when I did an office hours here almost. So because of that, that's what led them to believe that I would be a good fit for this. And you know what? My schedule was terrifying at the time. I will tell you, me saying yes was like probably a terrible, terrible, terrible idea to say yes because I did not have basically enough time for that. But I did say yes anyway. I want to take a risk on it because I felt like it needed me, so I decided to do it. Yeah, and even Alyssa said that I was like the first person that came to mind when it came for like this role. And I hope that I did a good job for everyone. You greatly enjoyed NixCon this year, and I kept it entertaining, and kept everything going smoothly. And I guess the main role of an MC is to hide everything that went wrong. So if it looked like nothing went wrong, then I did 100% perfect. But if you see a little bit that went wrong, you probably did. There was probably a lot more. Yeah, so on the topic of like my experience in this role, So I would say the greatest thing I harped on was making sure that everyone was checking their sound. So on Thursday, I basically did not sleep, and Puck, I don't believe, slept either, or maybe took like a nap. And I was basically doing that all day. I was really dedicated to that, and I just really felt like that was necessary to make sure everything worked. And doing that sound check basically ironed out like maybe 60% of the issues that would have happened during the conference that would have basically destroyed it. So yeah, I think one person's machine actually locked up completely when they try to do screen sharing, and that would basically took down their entire talk. So I was glad to see that we got that ironed out. So yeah, and I guess on the topic of having an online edition, like on its own, like it is a bit sad that we couldn't have a physical NixCon this year, but I feel at the same time this gave rise to a beautiful opportunity. I don't think I would have been able to make it to a physical NixCon because of my like schedules and availabilities and stuff like that. So it being an online situation, I was able to be MC. So you can thank COVID-19 for me being a MC this year, even though that would be a strange thing to even put any thanks towards that. So yeah, I would like to think that this was successful and a great option, and if possible, we could do some sort of online option in the future, since it seems to be it works just fine, and I believe we did a good job at it. And we also rolled all our own infrastructure to boot for it. So yeah, I felt like we added a great lightness to the situation by choosing to still provide a conference, because I know Nick said it would have been tragic to just not like have a NixCon this year. So we made do and we did it, and I feel like we did a good job at it. So yeah, does everyone feel I guess that's the closing for the retrospective on my part. Do either of you have any more stuff to add?
Not really. I think that covers all of it.
Oh, is that Nick?
Nope.
Okay, I guess this leads into the closing. Thank you everyone for coming to NixCon this year. I had a fabulous time doing this, and I hope you've had a fabulous time too. I feel like we did create that defined moment of just like, if you made it like mean something special to you, I hope that this was special to you because of everyone and all the contributions. Every talk given, even if there was one talk that we missed that due to scheduling conflicts couldn't be there, I still thank everyone for being available. Every talk was valuable. Yeah, that's how I feel about this. So on that note, we have a hack day tomorrow, and I believe that is on the schedule for everyone to see. And I believe it's just going to function as a join point for everyone to sort of hop in and sort of sync online in an online fashion. And I believe we will announce that. Will we announce that in some sort of like a stream way, or are we just gonna like post it somewhere? I wasn't really clear on that. Sorry for putting you on the spot like that.
Probably just posting it. There's no reason to start the live stream just for the notification that the hack day has started officially.
Right. Okay, so I would expect some sort of post, I guess, about the hack day for NixCon happening, and I hope all of you can sort of self-organize and hack and continue to talk about the talks that were presented at this conference today. And yeah, thank you. I feel fab. I'm probably going to sleep for like a month. I'm kidding. I'm not going to sleep for a month. NixOS 29 will not be released if I sleep for a month. So yeah, thank you and goodbye.
So, one quick note, self-organized. There's that pirate pad. I'll put it into the talk link and advertise it tomorrow.
Okay, great. So yeah, goodbye everyone. Thanks for being here.
Thanks.